you can have tremor part. So again, you've got these different layers, these different scales to structure. Bit of a delay. A big delay. No? Okay, so then you have genetic structure, population structure, and habitat structure, and landscape patterns. And then lastly, you have your function. So these are the ecological processes, so that you have a variety of different functions that each of these perform within the landscape. And these can also differ. A small example is the Media triannuera is a grass that grows in Kruger. In Kruger, it's palatable grass. In another area, it's not palatable. So its function is completely different, even though it's the same species. And it goes through a similar thing: genetic processes, population dynamics, interspecific interactions, and then landscape processes. So this is what our work package is focusing on. It's very broad, and we try to whittle it down to a few themes, but those themes themselves are also quite broad. And anybody who works with biodiversity, anybody in ecology knows that because this biodiversity has these multiple components and multiple scales, different regions and taxa, it makes it very complex. And that's what makes it fun. And that's why joining together these different disciplines in this room, mathematicians and physicists and ecologists and botanists and geneticists, I think that's the only way we're really going to understand this fully, or even just begin to start understanding it. And we delve into what makes this biodiversity so complex within this work package. And as I mentioned, the first step is looking at the patterns and just are sort of differentiating the different boundaries. For example, if you're going to look at classification of patterns, this is just to illustrate the example. You can use different matrices to understand these patterns. So a different matrix you use, you'll see a different pattern that can link to your understanding of the composition, the structure, or the function. And often it's just playing around just to see what the patterns that you're getting, how do those get formed? What is the underlying driver of that pattern that you're seeing? And the thing that we often forget is those interactions. So that's the one thing that's really interesting to me, is understanding the interactions within these patterns. So it's one thing to identify a pattern and to identify a driver, but it's changing all the time. The connections between the drivers and responders are changing over space and time, and the outcomes are then different. And that's a very difficult target to hit. And I often think of this like a spider web. If you were to pull on one thread, you're pulling a whole lot of different underlying features. And that's the change that we need to try and identify. So these are the preliminary themes that we've set up. They're quite broad. And I'll just quickly go through each one just to give you an idea of some of the stuff that we're doing and some of the stuff that we're planning to do. So it's divided into these 5 themes: the entropy and symmetry, complex adaptive networks, protected landscapes, spatial temporal dynamics, and computational tools for biodiversity monitoring. Right, the first, our biodiversity entropy and symmetry across scales, and this is to develop a unified framework to harmonize biodiversity metrics across spatial temporal scales, and addressing these biases and understanding these eco-evolutionary processes through entropy and symmetry. So that's a whole bunch of big words, and it's broad. But we put it broad so that we do have some flexibility in understanding what we need to do, because we don't always know. We work together in this group, and we come up with new ideas. And I think that's what's driving new discoveries, those discussions. So just some basic examples. Right, these are just, for example, patterns that you would discern from biodiversity using different matrices. We built this DisMap R package, and we're still finalizing it to be released on CRAN, but it's essentially a package to compute compositional dissimilarity and biodiversity turnover. So it is working, you can play with it. But this takes you through a process of identifying diversity, but within different scales. So it's not the simple beta diversity where you're looking at pairwise. You can start using zeta diversity, but you can also take that multi-site comparison to different matrices. So the package itself allows you to use different matrices to run those analyses. And there's a whole workflow associated with this. We're still publishing it, but it's on GitHub already, if you want to play with it. And yes, there's a whole guide online there to take you through it. Essentially, it's using these different matrices to identify these patterns. And a lot of our work is actually built on the idea of data cubes. So I think someone might have mentioned it yesterday, the idea of data cubes. So in this scenario, if you can think of doing field work, you've got your different sites. Each of those different sites has a number of different species occurring in different quantities. And then those sites also have specific environmental variables that are connected to it. So that link between the site and the species and the site and the environment, you can start looking at the drivers of that species turnover. Why are those communities there and how are they turning over in space and time? Similar to the species distribution modeling that Vernon was talking about yesterday. All right, the next one is structural emergence of complex adaptive networks. This is more Kang and Pietro's domain, but we have a number of students working on these areas. Mukta's, one of our PhD students, is hopefully wrapping up this year, and Richard Gibbs. And we also built this InvasiMap R package, which looks at assessing species invasiveness and site invasibility based on the site species environment trait. So it's the same as we had previously, but we add in another dimension, which is a trait dimension. Also online, it's part of a bigger group called the B3verse, which is a program that we're working on. So these are the different, but anyway, these are the different packages we built, but then there's a whole lot of other packages, and this is Mukta's package down here. So it's all online, you can have a look at it. And as I said, this is just adding on another dimension to the whole site species matrix, site species environment, which we had previously, but now we add in another layer, which is traits. And by linking those, we can solve this fourth corner problem where we link site, species, environment, but then by species and trait, you can link it back to the environment to say that these environments, these traits are doing the best in these environments, or these environments result in these traits, which can be invasive or not invasive in this scenario. So in this case, we're looking at invasiveness specifically. Right, then we have the biodiversity dynamics in protected areas. So this is a lot of the work that I do with SAMParks, and I think Judith's online. A lot of the work that I've done while I'm based in Kruger, so work closely with the Scientific Services Division there, and different projects that arise from management needs. What are the things that are going on in Kruger, for example, feeding back into what research can be done to help solve some of those problems or answer some of those questions that get fed back into management then of the park. So yeah, that because spatial temporal dynamics is so broad, we can work on anything. looking at environmental heterogeneity, distribution of elephants in response to different drivers, rainfall patterns and how they change spatially, temporally, the links within the landscapes, these different patterns. And yeah, this was one that Hank showed yesterday. That was very good cover. Then spatial temporal dynamics and adaptive interactions. So this is something I'm very interested in. So it's taking all of those spatial temporal dynamics that you see in the previous slide, but now looking how those interactions result in outcomes. So I'm just going to run through this very quickly to give you more animations and pretty pictures than anything else, but understanding that pattern is formed by process. You start from bottom up to see, well, you have your domain, biodiversity domain, which in this case we've got space and time, but then you build up the environment based on first your topography and geology and soil, which creates the vegetation, which creates animal, which changes the distribution. And then you have disturbance events like fire and humans, and then you end up with a pattern. But those patterns are changing over space and time because those interactions are changing in space and time. And yeah, it's just choose. So yes, you can imagine starting off with just basic pattern, looking at how the stationary drivers are creating that pattern. So there's underlying stationary drivers that create a pattern. With on top of that, you have dynamic drivers that are changing. So you can separate those and say what areas are more dynamic in terms of things that are not happening just within the template, the landscape template that doesn't change. Then you can look at rainfall, see how those patterns are changing. And I want to stress, that's why I put all these animations on, is that it's always changing spatially and temporally the whole time. It's this moving target. So even if you understand what's happening at this point in time, at this place, it's not going to be the same thing tomorrow. And it's definitely not going to be the same thing in a different national park or in a different area completely. And that's why anybody who's using remote sensing products that are globally created, you need to keep that in mind, because a lot of the time it's Northern Hemisphere calibrated. And there are often very few data from Southern Hemisphere that actually feeds into those models. So if you have local data, you can still use those global models, but just tweak it with your own data. Yeah, and that's changing all the time, especially in the climate domain with all the climate change issues that we're facing. Linked to that, so for example, rainfall is just not just rainfall, it's linked to surface water. So once it rains, surface water changes, that changes the distribution of species. So it's not just one driver that's changing when something like rainfall moves across the landscape. Then you have I think this disturbance events. Oh no, this is still herbaceous biomass. So that's just vegetation function essentially. Taking it from different remote sensing products. This one I think is fire. Oh, no, still not fire. All right, this is elephants. So in a protected area like Kruger, you have your habitat modifiers like elephants. Also have all the species in the landscape essentially that are altering the landscape as they use it. So understanding where, for example, an elephant is moving, you need to understand that they're also impacting the landscape that they are visiting. So they're drawn to an area for a certain reason. While they're there, they're also changing it. So you can't look at this as in stone. It's going to change the whole time. And this changing pattern is trickling down into other variables within the landscape as well. And complex structures of community structures like elephants, you have different sexual segregations. The bull groups move differently to the herd groups, and the bull groups can cause larger impact on tall trees than the herd groups. They generally, herd groups generally stick closer to rivers, whereas the bulls can move further into the landscape and use waterholes. So all of these things, you can't just look at elephants as elephants. Elephants within elephants, there's divisions as well. Yeah, and then over time, that's changing. And why that's changing, that's what interests me. And those are disturbances. So fire is changing in the landscape. And fire is changing. Why is it changing? I mean, there's all these drivers. There's rainfall, there's temperature, but then there's also elephants. So elephants are in an area which have certain composition of tree species. While they're there, they can impact the tree species, which then change the fire regime because now there's more grass, so they can burn more. So now, are the elephants attracted because of the fire regime, or is the fire regime created because the elephants were there? So there's this give and take the whole time within the system. All right, so this is just putting everything together. So if you take all of these different variables now, and you have the physical landscape variation, that's something that doesn't really change over the time frames that we're looking at. Then you've got rainfall, vegetation greenness, fire return period, buffalo, distribution patterns, elephants, river, etc., etc. Then when you start to look at the drivers of that and those patterns that you see, it changes. You can't say that I've got this pattern now, and this area is caused by elephants. Because it's caused by elephants potentially the strongest in that year at that place. But next year it's going to change. Elephants might not be the dominant driver in that area next year. It could be fire, it could be rainfall. And this is something that shows that these data, this is a study I did a while back, but I'm still trying to publish it. But it's such a nice paper. I don't know why it doesn't get accepted. It's so nice, look. But it really depicts this issue that it's a moving target. The drivers in the landscape are moving in space and time. And if you can't capture that and you don't understand it, you're going to mismanage. And I think that's one of the trickiest things with conservation areas in general, is that you feel like you need to manage and you need to do something, but you need to be informed about what's happening before you make any of those decisions. You also need to understand that knowledge that you generated in that point in time, it's going to change. So you need to understand the mechanisms behind it and how that changes over time too. So I'll go a bit quickly. So this is the last one, this innovative computational tools for biodiversity monitoring. So within this, there's different things that we've got on the go. Blue Sky thing, which I think I mentioned yesterday, was still to create this biodiversity information hub. So this was when we first started with Nitex. We had this as our key output, but it's an interdisciplinary project. I don't know anything about computer science. What I know is probably dangerous, and I figure it out on the go. So we need to have people that work together from different fields to make this work. And we did publish this, and we did have a special issue on this. And it's still our dream, but when that dream gets realized, I'm not sure. This year, I'm going to be trying to downscale a little bit and focus on smaller aspirations. So within the project itself, must we talk about things that we planned for this year yet? Was that later? Okay, activities. So I'm not yet.
I think you should wrap up with activities.
Now or later?
Now, I think.
Okay, now.
Yeah.
So activities, I'm doing writing retreats. So these really big workshops, I think they're really good for younger researchers because they can meet people and network, but you don't really achieve anything as you get older. There's no output from it. You can network, but essentially you've used a week that you could have started writing a paper, in my opinion. So I'm using the activities this year to do writing retreats. They're going to be in Kruger or the north, that area where no one goes. So if you want to come, everybody's welcome. I'm going to circulate dates and put forward the different topics that we'll be working on. So Vernon and I have done it already down here. I think it worked really well. We had a small group of people we didn't even know. So we tried to diversify and we got people from different departments together. And we made a lot of progress. But I think what I learned from that is we need to have a bit of a structure beforehand. So we have a structure where we've worked online with it. We send it out, those who are interested in working on it together, then we get together and we wrap it up. We made a lot of progress in that week, but I think if we'd had that one more, we would have finished it. I mean, we got really far, and it was really sad when we left because we thought if we just had 2 more days, we could actually finish it. But I think it really works. If you get a small group together, people that are working on the same question in the same paper, works. So that's my activities, and I'm going to just book them. So whoever wants to come can come.
Any comments from WP1 folks?
No, I can wait for them.
I think we have quite a number of WP1 folks, huh? Yeah.
Yeah,
So,
I think I already spoke to them. I told them we're doing writing retreats. I don't know if there's anyone online. I can't see.
I think I would fit very well in WP1, and I would really like to participate in this because it also feeds into my need of having that level, that dimension. When I said that they can be very flat, you know, some technical practice, ecological information. That's exactly how I feel about Fungoda. So I think that it would be extremely productive for the genetic this collaboration with the agriculture of our company.
Maybe I want to just ask about those Kruger factors. So for example, I see like the buffalo data set. How do they get that data? Is that aerial counts or is it like scout counts or what's that?
Aerial.
You guys?
Yeah, so the buffalo census are buffalo and elephant are helicopter census that they fly in winter. So that's also something you need to know is that those patterns are winter patterns.
Yeah, so that's also again, but I was wondering, you know, when I look at this type of things, and I think this is sometimes where, you know, like you say, the management actions, because Kruger's got a lot of resources, you know, there's a reserve, big government puts a lot of money, they make a lot, but on the provincial park levels, where you don't have any of these resources. So they tend to look at Kruger or SANParks and see what SANParks does, and then they adapt to their landscape. But I mean, it's smaller size, everything is different. So, you know, I'm just getting a feeling that there's like a mismatch between what happens in SANParks, for example, and what happens in like all the leaded parks we are involved with in Limpopo. I mean, the average size is 8,000 hectares, they're not very big. And they tend to do a lot of management. They move stuff, sell, buy, up and down. So I don't know if that's anything related to any process, you know, it was maybe market driven, I don't know. But I was thinking, you know, that might be a future idea or a thing, you know, to actually go to some reserves, provincial parks, that does also management for biodiversity, but it's not informed in any reality probably, I don't know.
So the pictures I showed was for Kruger, because they were pretty, but I'm working with Mike Peel. I think you must know. Mike. Yeah. So he's long-term data sets across all those private reserves in the perimeter. And he's coming down for a writing retreat this year as well.
Yeah,
we're
but
working
again,
together
Mike
on
Peel
that.
works on these private reserves, lots of money.
Mm.
You know, I'm talking like Loba, that's the budget of, they got a budget of 50,000 rand
Yeah,
a year.
yeah.
Uh,
But that's important. So
Mm.
come to work package 1,
yeah,
because that's the way that we can highlight those
Yeah.
mismatches and to say we need money for this.
yeah,
Because those smaller parks are overlooked. And they're also small enough that you can measure. Because Kruger's got resources, but it's also so big. I mean, you can't monitor 2 million hectares, no matter how much money you have.
exactly. Yeah.
And in smaller parks, you can actually see direct changes in,
Yeah.
you have a management action and you can see the results and you
Yeah.
can then change it.
I
It's-
think that's
it's-
important because the what I've just seen from all the small researchers, you know, they tend to feel like they're neglected research-wise. Nobody does research, nobody does anything. You go to the Savannah meeting, there's no representation from any small parks, nothing. So, you know, you get this, people feel like disconnected and it's like, what's the point?
So what do you think is driving that? Because
Well,
the,
it's probably a lot of this budget-wise, you know, there's no provincial budgets, it's not very high budgets. And I think people are overworked, there's not a lot of capacity. But even if they collect data, nobody uses it.
but maybe it's because the data aren't advertised.
And it's
Because
not in the format that researchers want. We talked about it this yesterday. Nobody wants to sit we want
Yeah.
the clean data sets. So
That's
that's
right.
probably one of those things I'm trying to even say from my side. You know, in that whole area where we are in November, there are probably 55 type of reserves in that landscape that collects a lot of data. But it has to be cleaned somehow and fits into a pipeline like this here. Yeah, I saw that paper as well. So that would be, I think, you know, a very good I guess gateway into those reserves. And then from that come back to feedback, help say what's the output, what's the point. I mean, you know, like something like Blouberg, where I am, has got the largest colony of whiteback vultures in that area. And the reserve manager does all the management. He counts them with binoculars
oh wow, sure.
for like 20 years.
Yeah.
And that data is no, I mean, we've tried to clean it now and things like that.
So what does that data look like? I mean, do you have a lot of paper copies or is it digital?
Some of them are paper copies, some are just spreadsheets. And remember, this is now from Windows 95.
Quattro Pro.
So they sit with a lot of that stuff. So paper, you know, probably have to be scanned in. So, you know, I think this is a really, this biohub here, I think it's really important for, and I don't know KZN and these parks, but I mean, Limpopo and Mpumalanga, you know, there's a rich data sources sitting there. And it's just not in a format that's user-friendly.
And that was the dream of this, is that the system is supposed to be open source, but it also doesn't force one to share the data.
Yeah.
You can use the system to clean your data and curate it. But until you're ready to share, it can sit there. But at least in that way, you allow the data to be cleaned and processed so that it is ready when someone is ready to share and ready to work together. But one of the things that I've been working on in my spare time, because we haven't sort of worked out how to integrate data science and computer science, is taking those scanned copies of data and digitizing them. Because so Mike has got a big data set of paper copy things that they just captured by hand, and then made it even worse is that when someone finished it, they put a line through it to say it's done. So now the 5, when you try to extract it using machine learning, it's got a line, it's different angles, and we're still trying to figure out how to deal with that. But if you have written text that's separated nicely into a spreadsheet, our workflow works. We can extract it. But as soon as it gets a bit complicated with lines and squiggles, then it gets a bit difficult.
I think a lot of
that's what I think is important.
Yeah. A lot of this stuff is quite important, but also very interesting what people record. You know, a stupid example is many years ago, we saw a lion killing a mongoose.
Mhm.
And me and my student were looking at it, and we wished that I thought, how frequent is this?
Mm.
And we met a manager for a game reserve, and he said, but this happens all the time.
Yes.
I'm like, really? And he's like, yeah, they had like a notebook, and somebody recorded this stuff.
Exactly.
And we read through this notebook, and I see, oh, come back from the drive,
Mm.
lion killed 2 mongoose, things like that. And that whole thing set up a whole project.
Yes.
And we just went through data, people's written notes, the game ranges and stuff. But if you read through it, there's so many interesting stuff that they write down, this river was flooded, or,
It's
so,
true. I mean, that Gordon, what's his name? They're up there by that dam, Schroeder Dam, the tigerfish eating
Yeah, yeah.
birds.
yeah,
I mean, people
Yeah.
probably seen that before, but he saw it and he wrote it up, and it was a big,
Yeah.
big thing. I mean, in Lataba, I remember the students there, they used to watch the kingfisher, the woodlands kingfisher catching bats.
Yeah.
Every day. And then they had veldfocus.
Yeah.
Some guy took a picture of it, and I don't know if he won the Land Rover, but he won second prize, and they've been watching it for the
For
last
years, yeah.
3 years. So yeah, it would be nice to capture that type
Yeah.
of stuff. And Barbara had something, and then Kevin.
Yeah, I was thinking that the people on the Billboard very often they're not as connected with this sharing of their research as we do, because they are less familiar maybe with the formal publication process. So maybe an incentive system would make a huge difference for more people.
Yes.
Sharing their data and
Yeah.
their locals somehow, so that they feel recognized,
Mhm.
acknowledged, and they get something in return.
Yep.
And very often they need very simple stuff.
Yeah.
Like what I need is what I need, my dream is to have a new pair of binoculars or
Yeah,
something like
yeah.
that. It's something that things that are quite big.
Mm.
And that can make a huge difference, and they can work as incentives for people
Yeah.
who are not so motivated to publish, to at
And-
least make their data available.
And often it is data. I mean, we had a whole discussion on Friday about this. Maybe we should say a whole fight about it.
Of course, NETAX will not buy the binoculars.
No, but often the issue is that they actually want to clean their data. So if we can help them publish the data,
Yeah.
but they're first author. So essentially you help them distribute that. Then that data, their legacy will
But
always be
what-
there
what-
because when they use it,
Yeah,
they sign.
The thing is that maybe what we think is like the price for us, which is authorship and publication.
Yes.
That's often needed, and we see that as a huge price. For a
Exactly.
lot of people, this is meaningless. That's not what they want.
And that is such an important point.
Yes. So
Because
should
we
identify
keep sitting here saying what they want.
what- Exactly.
We need to ask what they want.
Yes,
Yeah.
and
Yeah.
maybe they want to buy up.
Exactly. In which case we'll
Well,
use Can's budget.
We could consider that as an invoice.
Mm. But no, they won't want binoculars. They're not that.
You give us an invoice. to
I'm
Purchase
sure.
the data.
Oh, for the data.
It should be incentive, acknowledgement, reward in stuff that's meaningful to them,
Yes, that's true.
which is not necessarily what we think
No,
is
it's not. No, definitely. Kevin?
So I'd like to start by saying, apparently there was a prediction last night that the bad boys wouldn't make it.
Oh, yes,
And I'd just like to say,
you may.
well, more than that, our transport did not arrive.
Oh, no, shoot.
we were up very early.
Yeah,
Where are you?
we're quite
sitting?
far. We could have walked, but
Yeah.
it's a long walk.
How many minutes?
So, no, have we walked it
We did walk it the other night.
the first night? Yeah,
I don't know.
but
It's 2 kilometers, that's quite far for us.
No, it's not. You do field work.
some of the guys had
Very
their,
for Kevin.
some of the guys had their furniture with them. What's
Yeah,
that
the
called?
bags.
The luggage.
Oh, shoot. So did it arrive eventually? Okay, you phone Hundley.
Right? I phoned
did you-
Nelly.
Yeah.
And she apologized, she forgot.
Okay.
But anyway, that's not what
All right.
I
I was
asked.
gonna say, sorry about that.
I just wanted to clear that up. So that looks, we came in a bit late, but it looks fantastic, all that stuff. But how much does it really? No, that's not the right way of putting it. How easy is it to use it or translate it as a manager. And like all those, I think instinctively we've always known that there's drivers, there's different things, it's all going on, but you've now quantified it to a point. And I'll ask my other one before you even answer that. To what extent does management become a driver? Because I've always worried about that, especially in Kruger Park.
Is that the end?
Yes.
Okay. So, yes, there is always this have to translate management and science, and it's built on, again, a system of trust. So that is a very tricky thing to build. Some parks get it right, some parks don't, and it's driven by personalities often. But at the end of the day, the only answer is that everybody is in the same room when they're asking a question. Once they find these questions, it shouldn't come from this room. If you want your research to have an impact on management, you have to ask management in these parks what are the issues that they're facing. Maybe it's not an issue, but it is an issue for them, and you need to talk about it to be able to identify the issue or the question, and then work with them and get students involved on a project that might not even interest you. But if you want to build that rapport and have your research matter, that is my phone, sorry. Looks it. Then you have to start that dialogue, and it's not an easy process, but it is an important process. And this isn't going to solve it in one day. I'm not saying that this research is going to all of a sudden change the way Kruger is managed. It probably won't, if I'm realistic. But I would like it to, and for that to work, you have to engage. That's the only way you can do it.
Sandra, I'm thinking like you have to package this as deliverables for specific data set. Like my peer you're gonna work with, my
Yeah.
convert that data through this pipeline to a BOI paper and so on.
Yeah.
Yeah.
So we have
And
those.
you can also discuss with Lawrence
Mhm.
and see whether there is also through the same pipeline and so on. But a big thing is you have to think about the capacity.
Yeah.
Your overworked.
Yeah. So what I'm going to do now is we've already got papers that are lined up that we're going to do. We've already got a working retreats, writing retreats planned. So I will circulate that to everybody. If who wants to be involved and wants to join, they're welcome to. If you join, you will be working. So don't just join if you want to fix the references at the bottom. But everybody's welcome to do it. We have ones that we've already identified for this year, and hopefully next year we'll have more and we'll figure it out. So from next year, I'm not with you.
What work exactly?
Depends what we're going to do.
I mean, I see writing retreats as silly things that you take students on to teach them to write.
First one I did was with Vernon. Well, you have to tell them that you liked it now because I put you on the spot. But I really enjoyed it. We actually did stuff, which was so good.
But what stuff? Because you've obviously got the data and you've got the ideas and you've probably got the analysis even.
This one.
But then what do you do?
So, I mean, Sandra is right, but we went there with a broad idea, which is maybe not the right way to do it, because it took us a day or so just to actually sort of refine what we were going to do. So we were looking at these carbon accounting methods, they would want to discuss. A lot of these things focus on forests worldwide, but they're applying these methodology. Yeah, so we went there. I think we should have prepared, but when we were there, like we got a lot done as we have this scaffold of a paper.
It's more than that, I think. It's even a draft, and it's split now into two.
Yeah.
By the time we left, we had a full pipeline We had a notebook in Jupyter Notebook that extracted all the data from Google Earth Engine and could run through an entire pipeline for South Africa, and worked. Now it's essentially writing it
And
up.
how many people were on this?
Which was another thing. We invited people we didn't even know, so we still had to get to know them. Okay, you bought, I want to say, yes, you knew him, but everyone else we didn't know. So it was also getting, understand each other's work process. But that was you, me, Aru, yeah, I have 5 or 6, but it's small. You have to choose the people right. You can't have big, loud names. That's how we felt, because there are big, loud names that take over the discussion, and then nobody has a chance to speak. And we wanted everybody to have a chance to have a say. And I think it worked quite well. Maybe the next one doesn't work so well, but I was pleasantly surprised, and I think that's going to be a way to actually get papers out, rather than these big workshops where everybody just talks, no one does anything, like I've just done now.
I know that you were included, so I expect to see a lot of maps that would be coming from your wood. But philosophically, do we associate biodiversity specifically with national parks and nature reserves and protected areas? What happens because in my specific work, I rarely do anything like something inside the protected areas. So I don't see biodiversity as something that is inside. I see that maybe because of the species that I deal with. So
it complicates it very much so. And I actually, in here, I specifically said protected landscapes in one of the themes, because the ideas in the protected landscape don't translate outside. So heterogeneity in a protected landscape is good. Outside, is it not fragmentation? Because it's chopped up into little pieces, it's then heterogeneous, but it's about the type of habitats that are there.
Monitor more intensively protected areas than outside areas. In the future, is biodiversity going to be restricted to protected areas? Is this how it's going to unfold? This can actually.
Yeah, that's a very tricky question, and philosophical that if I start, I won't stop. So let's chat afterwards. Yeah, because it is. We were chatting last night about, was it us? Someone was talking this video about protected areas and biodiversity becoming a commodity, and it needs to be protected. How we do that needs to adapt, but these large protected areas and wilderness is something that we need to, at all costs, try to protect. In my opinion, doesn't mean outside isn't important, but I'm going to cop out and say you do that, I'll focus here.
But you see, nobody does it outside.
Yep.
Because every researcher wants to work in Kruger.
Exactly.
So that's no, I know, but this is a very big problem we all have. And what we have been trying to do up in the north, there's a whole biosphere, and then there's a Vembe biosphere group. It's supported by UNESCO, so they've got a manager. It's got a whole about 50 young people in this Vembe biosphere. And what we've tried we're still doing it now. We try them all to just use iNaturalist now, just to record as much as they can whenever they're in the field. So just to try to build up for the Vembe biosphere data sets. And I must say, I think we got about 60,000 hits already in those groups. So they're collecting data. It's quite actually going up.
And when you plot them, you can see the
Yeah, but you can exactly see, if you'll see Kruger and some parks, not much in between, because even the student feels
What's the
protected
point?
areas is where I should record, not on the
Yeah.
road where I walk.
Yeah.
So that's the barrier to break, to say that biodiversity is everywhere, it's not in the parks.
Yeah.
Thank you, Lawrence.
Yeah.
So even
Yeah.
even the students, when
Yeah.
they enter the gate, they start to take photos. You're like, but why didn't you take outside? Oh no, but that's not protected.
Yeah.
Yeah.
So this thing, the people feel protected areas is the beacon of biodiversity, not where I live.
But are you talking about, are you excluding small nature reserves out of that? Are you saying in your backyard?
Yeah,
Backyard is everything.
everything, your house,
Everything.
the farms, game farms, communal land, anything. Urban doesn't matter. So that's what we're trying to get them to do, is to just record biodiversity wherever. Doesn't
Yeah.
matter if it's in the village, in the settlement, or whatever, to build up some data around that, for the bio. But
Yeah.
that, in my opinion, can be. I think that would be a very powerful thing, is to. So we work with our naturalist from Sandby. What is the lady's name? Silvana. She does all this training for INET. She comes to university and she explains what iNatural is and what. So we get her to come and talk to the students. Not a lot of uptake, unfortunately. I don't know why.
Yeah.
But the thing is that might be a nice circle to run. Year one, get all these biosphere students and communities to just take photos as much as we can. See how much comes into iNaturalist. Make a very small paper, just something to say, but involve that group
Yes.
in that, like you say, writing it, getting that students to even clean out, download the data, get them through the pipeline, that they can see what it translates to, and then try to get the because the biosphere is this classic thing, buffer areas and
Yeah.
transition areas
But
and
the biosphere is a different, so I agree, all biodiversity is important, and I do think you're right. We do need to shift to look at biodiversity within these urban or peri-urban environments, definitely. But at the same time, they're not under threat as much as these protected areas. So in the biosphere, you have small protected areas, and I think what's interesting there is using that information in the urban area and peri-urban area to create corridors to link these, so that those protected areas can stay protected while also considering that biodiversity is not just within those areas.
But
yeah.
associate biodiversity with protected areas. You should see it as something that's with the kids.
It's true, but you don't have to protect your backyard. You can protect it.
That's exactly my point, because areas are protected by definition.
They are
Right.
now, but we don't know what's going to happen in the future.
Right, but your backyard is much more vulnerable because it's not considered biodiversity. It's not protected anyway. So that's exactly my point.
It's true, but it's also scales. I think, let's chat about this at tea. I don't want to take away the whole.
I think it's an important
But let's
discussion
chat,
because
yeah.
this is exactly what happens. People perceive biodiversity outside as non-important,
Yeah.
meaning remove it.
Yeah. No, no.
If you look at your map for Kruger, you will just see the boundary of Kruger. It's a hard boundary now.
Yeah.
Yeah.
Because people perceive biodiversity in Kruger.
Yeah. Yeah.
So they don't care up to the border of Kruger.
I mean, of course, it's easier. That's also, I mean, that's why I'm in there. Kruger is an island. There is nothing, it's tough.
Yeah.
I don't have to look outside, but it is really important outside. I agree with you.
For instance,
But it,
the people working in the Kruger part is super difficult. And all this stuff. So it's much easier.
yeah, but I think there's room for both. That's the point. Is that you can't discount protected areas just as easily as I can't discount peri-urban and urban areas.
This dichotomy is unique to South Africa. The
Yeah,
rest of the
because we have these type of environments.
because we created these boundaries.
Yeah,
I mean,
but
the rest
we're
of Africa's
also,
gonna face it, but these hard lines.
we have, but we're stuck with them now.
No, I know.
Yeah.
I know.
And
the street.
rather than dropping fences and saying, all right, let's.
Let's go back, we can't.
Exactly. So we have what we have and it's protected, but at the same time, I agree with you that we do need to generate more awareness about what's outside and that you don't throw it away just because the boundary stops there. It's important and we do need to consider it and then build corridors around it.
That's a whole nother
Is, yeah,
fun fight.
exactly. Okay.
Okay, so,
Whoosh.
so just make sure, because I understand that, of course, you're overcommitted a lot. And so reading work picture 1,
Yes,
you have a list of items.
yes. The papers.
Yeah, you're gonna assign to someone in charge, or you're gonna be in charge.
Well, the ones that, yeah. Yeah,
Because we're gonna.
yeah, Vernon and I we're going to finish that one paper. But then there are other papers that, yeah, so I will circulate and see whoever is interested. If it turns out that you end up taking a lead because you're more interested in it, you're welcome. Be first author. We want to collaborate. It's not about me coming and saying we're doing this. So there are some of those because I am doing that, but the rest of it. But
So you're gonna
I'm gonna
run
stick
through
with
the.
yes, yeah, I'm gonna go through the Stellenbosch hub. But I have a new plan that will work administratively. I've got a new.
We're gonna now jump to Tess. So you're gonna present the work package 2. Because Tess is the only participant in work package 2 left in this meeting, so.
Did he present it already yesterday? I don't know if it's the same.
Yeah, I just wanna have a quick discussion on that. The activities.
Thank you. Just be like. No, but.
Yeah. People trying to reach you, these cases of abuse. We schedule a meeting, basically. People on.
Discuss work package 5.
Yes,
Okay.
I've got nothing much to say, but I'll say something. I haven't got
And I think there are 2 work. Just gonna ask them.
Morning, everyone. I'm going to present again yesterday's one, but I'll go fast through it. Because I was not now I'm going to present it, but yeah, lately our field coordinator, she was in another commitment. But today, my focus is just to include the budget part activities. Yeah, as we mentioned, the environmental modeling cause is very crucial as environmental interaction and the complex system is very challenging to handle. The big data and it's a complex system. So we focus on the modeling part and more of the method, how to use different approaches to integrate all those parameters or factors in the environment, in the complex system like hydrology, air condition, ecological system, all the climate, and very complex. In addition to that, the data by itself is very huge. Then the uncertainty or changing of environment by itself also affects the forecasting or predicting system. So even the data gap, which both spatially and temporally, depending on the landscape conditions, the geology, the environment, then there's the land use, land cover change, and the land-based activity, all contribute to that, affect the whole system of the environment. So it's really crucial to consider this complex system together to complement what you already presented on the mentioned, because all come together one to affect. So understanding this environmental system using the integrated modeling approach is important. In addition to this collaboration. So in this we will achieve like some predictive modeling. Even we will develop the modeling framework, because for the uncertainty, the data should be verified or validated. Most of the data will come from satellite, the ground truth data verification, or the uncertainty handling, and the verification is important for until to use at evidence-based decision support production of the modeling through checking the sensitivity and the uncertainty analysis. That explicitly included more quantified system for that key variables in environmental risk assessment, like wind direction, air quality, drought, flooding, all the climate risks. These are real challenges and the risks every environment community is facing in the whole world in different time. But the uncertainty is very high. So in this, we will use the statistical method. Like this one is an advanced one. We will use which consider or handle that data gap fields and the changes in the data based on the environmental condition in ecological, land use, hydrology, and pollution, both spatially and the temporary analysis. So in this 20 and 26, we will focus on integrated Earth observation data. There are different data sources from satellite, Sentinel, and Google Earth Engine platform, the NASA, and the reanalysis of precipitation, evapotranspiration, and the land cover data that will focus especially for water resources. For example, yesterday was presented about yield estimation. That all depends on the water stresses. So we will determine that risk vulnerability points from satellite of Earth observation data, even drought and flooding mapping. Predictive modeling through robust methods for wind direction, even the time series for forecasting in the segmentation of that temporal detections. Extreme precipitation and risk modeling using this Bayesian modeling approach. This approach help to understand the data gaps and consider the data filling, and advanced spatial modeling for conservation, because the context of those parameters changes spatially, temporally. So let me go fast, because you already have this observation. The integrating of Earth observation. This is the current important important data information, because it considers the long time data and the data continuity, and because of the data available for sparse range station for data collection is not updated. So using this satellite data is important. Spatially, how it's distributed over different area, we will consider that spatial data based development. Risk identification and the modeling. Is this the important thing in order to take action or to prioritize monitoring, instead of considering the whole catchment or area, specifically addressing in using the vulnerability or risk area is important in order to take action. So risk mapping is important for water scarcity and the drought-prone area, even the flooding area, which support the water management, both for industrial, agricultural, or domestic water supply. So risk identification and identifying the priority area for monitoring is important. So this study shows different locations in high, low, moderate, and risk areas with a calibration and a validation based on some available existing data through model training or the real-time satellite information. This is our focus. Focus is on modeling prediction, and methodology challenges will be addressed, and the data gap is addressed in this predictive modeling of, especially this in the second stream. The third one is more of temporally in the forecasting in how in the future the region for the rainfall or some climate variables changes. So considering that variable changes in specific, for example, rainfall patterns, how it will change in 100 to 200 millimeter per year rainfall or per month rainfall. And what if the rainfall is highly extreme? So considering all those parameters in this study that affects, for example, the water resource, how it changes with rainfall patterns or regions changes, how it changes with evapotranspiration, how it will change in the land cover, land use changes. So this interaction and interrelated analysis is very important to compare the most impact features in that that interaction. So even the sensitivity analysis will help in that approach. So this is application in the monitoring system, which even enhances the prediction capacity. In this fourth, the stream will include of application of the integrated nested Laplace approximation to precipitation modeling. As I said, the precipitation it changes depending on the environmental condition, topographic condition, and the landscape. All changes that. So considering that topographic or aerographic effects is important to consider. Even as said, all the data or train in the north-north context. So how it will look like in our condition in south-south geographic conditions. So that uncertainty using this Bayesian modeling will help to understand the precipitation patterns. The last stream in this is spatial modeling, especially focusing on the marine environment for megafauna conservation. So this system apply to handle the complex system. The previous, most of the time, the studies consider a single parameter approach or some of the approaches, but how we see all parameters together in a one platform, like this machine learning AI approach also will help to understand all this correlation between different parameters, especially in this ecological system. So all this is a planned activity. So we will have the E5 wide one workshop overall. And the other workshops depending on the sub-streams, like on Earth's integrated hydrology or predictive modeling or time series analysis. Each one of them must potentially have one mini workshops or science meetings. Or we will expect to deliver 5 accredited publications. They will have a scientific communication, maybe a conference presentation or publication showing the output effectively, capacity building through involving postgraduate students and usable framework for methodologies development. So this, in summary, we will focus on modeling and looking for funding for support for this possible. Maybe that is the question come to, is it possible to fund from other sources instead of only from NITEX? So this is a budget-wise. So we will have about 100,000, said 100,000 rand. So we will have one EW focused workshop, but specified to WP2, which estimates about 45,000 rand. The other EWP mini workshop or science meeting is we have 4 participants. each participant will allocate about 15,000 and use for this science meeting or workshops. Okay, that's all.
Yeah, I quite like the clarity here, even though the project itself is lots of methodology, which is fine, but it's unclear about which system you're applying that. I saw you have mentioned some Red Sea, some other wind and so on. So
Yes, I had the same question.
yeah. So I suppose reading WP2, you have a clear understanding of the system that you're gonna follow.
Yeah,
Where is it, basically?
the,
You have a site, or what have you got in mind?
yeah, EWT more all come together on environmental modeling. So we have different members. So each team member propose a specific activity. Yeah,
No, that's,
Yeah, maybe for example, Tess, if
Yeah.
you're one of the participants, you know? So
Yeah.
you're gonna run a workshop.
Yeah.
And in your mini workshop, which system you're gonna model? Do you have a plan for that?
not yet.
see, I thought maybe, I was thinking about it. Okay, you use all this to then apply it to W package 5, where we've got a place. And
Yeah.
less of an idea of how we're going to model it. But anyway, we'll see. Do you understand that? I mean, well, you're here when I speak.
Yeah.
I'm talking about a specific question. In KZN.
Sorry.
So are you willing to work with work package 5 to address some modeling specific actually related to relevant to work package 5? Use your modeling method.
Or have you already got an idea of where you want to apply it? Or you're just developing stuff?
We are just developing the stuff.
Well, look, I don't think he needs it. We can interact.
Okay.
I can go to him for assistance because we might have our own ideas. 'Cause I can't talk just for my group totally.
Those methods is
Yeah.
already there.
Sure.
Look, lots of us actually use all those different methods, yeah? So Bayesian, Ziegler, the problem is you have to apply that to a specific system to lead to a deliverable. And are you proposing that this work package 2 is developing, but advancing that method?
Yeah.
That's quite a hard. Yeah.
That's because that's the question I asked yesterday,
Yeah.
presented, is that these themes that you've put up and these things that you want to address, are you presenting them to say, we are interested in testing these methodologies? Who can we work with to do this? Or do you already know how you're going to do this? Because if you're here to say, I want to collaborate and these are the questions or these are the methods that I want to test, then it makes more sense to join with another work package and then work together. Whereas if you've got ideas already and you say, I am doing hydrological monitoring in the Drakensberg and I have these people that have got the data and I'm going to answer this question, then that means you're a separate work package.
I mean, you talked yesterday about data.
Yes.
Where was that data? You were talking about spatial data yesterday.
So initially, the initial idea, for example, I am one of the 4 members. So mine belongs to the stream 1, the Earth observation data. So for a specific area, if I propose for example, the Western Cape region, I will use the satellite information for its observation, which focus on water resources, for example, drought or flooding. Yeah.
Yeah, exactly.
So,
Okay.
There is obvious kind of potential issues. Because in Stellenbosch, we have School for Climate Studies. They have a whole team working on hydrological modeling. And it's also part of the Earth system modeling. Andrew Watson is working on that. And at UCT, yeah. SEEK or ACDI doing hydrological modeling. So how do you, like, which system are you going to work on? It's impossible for you to work on South African, like the entire hydrological modeling of South Africa. You have to be precise. Otherwise, we don't really know. It's kind of like opportunity publications. We don't already know which system. It's just at the end of the year, you can report the outputs fit into what you could have done. So it would be great, I think, if you can chat with Priyanka and work and just pin each deliverables activities to a specific system. Yeah, because those model itself, to further advance that model, like Bayesian inference, those type of models, that has been there for 100 years. I mean, how are we going to advance that? We're not going to rewrite the Bayesian rules. So it's mainly like implementing it. So implementing it for a specific system and hydrological modeling for a specific watershed.
So I've taken this comment as it is. But what a big difference what you have said, who the others doing will focus on machine learning, the AI system, how it looks like, what differences will come because of that using of advanced tools or methods.
I think also the key there is the link with the right people, because we need to link with ecologists or hydrologists or geomorphologists. I mean, I'm not an expert in that at all. The danger is if you're from a statistics background and you're focusing on environmental problems, you need to have someone with an environmental background that helps guide some of that understanding. So, it happens in maths all the time, that there's a problem that seems like it's simple to solve, and you can sit there in your math silo and work out a solution that's mathematically correct, but is it ecologically correct? And you won't know that unless you have inputs from the right people. I'm not saying I'm the right person, definitely not from hydrology or geomorphology, but that is a very important link. And I think that's what NITEX is trying to do, is that they link people from different disciplines.
Thank you. I'll take this for our team discussion as an idea. Yeah. For me specifically, I have confidence because I'm a geologist. I studied 5 years in geology. My master's is in hydrogeology. So I am my PhD in environmental and water science from UWC. So I'm a GIS and a remote sensing expert. I'm now ArcGIS, QGIS. Now I'm using the machine learning. So in my PhD, I used the climate and the land use impacts on groundwater quality. In the case of Cape Flats Aquifer City of Cape Town, so which is published in a prestigious journal.
I mean, that's
So, yeah,
brilliant.
yeah, that's,
I mean, we're not questioning the skill sets.
Yeah.
The competence of WP2. We know those few folks, yeah, Priyanka and they're very statistically strong. We are asking which system you're gonna apply to, yeah? So you're gonna test your machine learning based in inference, different advanced models, methods. For instance, we can say hydrologic modeling of Cape Town. I mean that then we can consider we can think this project as relevant.
Yeah.
Because otherwise, if you only justify machine learning and Bayesian approach better methods than the frequencies kind of method. That's also fine, but to be like relevant in the E5, we want to link that to specific ecological, social economic system. So if you say hydrological modeling, Hungary, then that's a valid project to us. Yeah.
thank you for this very clarification, because that was the very question I asked yesterday. I was confused. In study area context, really where we apply.
Yeah.
So my question again for you. So all WP2 belongs to, applies the same area context or different methods but different area?
No, you decide.
Oh,
Yeah. So for instance, work package 5, it's mainly KwaZulu-Natal. Yeah. So we're gonna discuss WP3. It's in Venda area. So similar methods apply, but we don't have a Western Cape one. We can have a Western Cape hydrological modeling for the Silver catchment.
But that's
Yeah.
also why I asked about if you're advertising to say we want to collaborate. Because, for example, I'm working starting now. That's after the floods that have been happening in Kruger. I got all the data for all the river monitoring stations in the park, and I think I took 20 kilometers outside the park for as far back as I could get. So some of them are 1960. Yeah, long history up until now. And I was going to start working on that, and then I was going to start learning from scratch all the hydrological stuff I need to know. But if you're a hydrologist,
No, you don't. Yeah.
then
So
let's work together. But if
Yeah.
you've got your own priorities, I don't want to squeeze into your work page without being invited.
I'm interested in open that kind of collaboration. We are here because of that. Yeah, I think. Yeah,
So then we must
to work together. Yeah, thank you.
Thank you.
well, we know we have lots of capacity. From work that we have to identify which one you want to work with, invite them to your specific task. I think next is work package
Do
3.
you want to break for tea?
Yeah, maybe
Have
we
some
can.
coffee and then work package?
But can I ask, Lawrence and Barbara, you two have to think about it, but pioneer warm activities. Yeah.
And you're not allowed to be negative. Be positive. Yeah.
I think, I don't mind, but I would. No, Mopani worms is one thing, but I would also like to have the biodiversity component into it. Yeah.
Yes.
Then it's fine for me, because that's the two things I'm very interested in.
Yeah. It does not have to be species specific.
Yeah. Well, it's good to have a focal species, because
Yeah.
Mopani worms is one, it's not this, it's an ecosystem rather, because it's, very, I'm gonna say linear, Mopani worms, Mopani trees, people, there's not that much complication.
So I think online or so the work have more participants. There are two others.
I'm very confused about these numbers.
Yeah.
When you say work package 3, I don't know what you're talking about.
Kevin, we have to make a decision because the two colleagues from Northwest University, they want to participate, but they're not in the meeting.
They didn't come to the meeting, and did either of them express a desire to lead anything?
No.
No. So whether they like it or not, they're now part of this
Yeah.
package. And I don't even know what their skills are. Do you? Who are they?
They are all like both environmental modeling type. Yeah.
Well, you guys have to get on.
Is it, do you know their names?
I think you might know them. At least just let me check.
Peter's died. So I'll look it up.
Jared Robler and Sean Liebenberg.
Okay, I recall the names, but I don't know them personally, but,
I mean, if you become work package 3, then you decide how you want to run it, and you will meet probably
Yeah.
and decide if it's going to work. If it's not going to work, do something else, or you disband it, or this is not a Nazi organization.
Work package 3.
It's got a name.
It's not in my mind of these.
Work on them, you can rename it.
Yeah.
One with insects.
Oh, it was the one led by Ruan. Solved.
okay. So it's like edible insect type of stuff.
Worm is I can't think.
Yeah. Okay.
Is it that I don't want to be dissolved without even knowing that I was dissolved?
There's harvest, you know, like the interaction with the trees, local economies, issues are really out there. I'm thinking like you can design a dynamic model. You can also do lots of spatial model.
I think there's I mean, we were just chatting about those absent models, but I imagine you can develop the same model to grow trees. A number of leaves will equate to number of worms, data of that. So you can probably estimate yield. We just don't know if the yield, where is it coming and when is it coming, but those type of things we can play with in terms of scenarios, and then
Yes, and I have ideas for scenarios that I feel that we should need to explore so that
Yeah.
the role of the mobile worm in the ecosystem becomes more.
well, I think, you know, so there's a lot of things we can do. And I just listening, there's lots of people who've got skills that because my computer skills is not very high up.
Support, yeah. Also, WP2,
Yeah,
all statisticians
exactly.
waiting for a system to work.
Yeah. We must make that workshop and then put everybody together and be driving the whatever comes out.
So we can also discuss a little bit, where do you want to park that ring fence to budget to?
Yeah.
To know when the Stellenbosch or Northwest.
Northwest, but
That,
it's not even needed.
Yeah, no, I'll not park it at Venda because you guys scared me with the amount of admin you have.
Let's just check with Nitex exactly how it works, because if it goes to the node, the leader of your area is Northwest, so I don't know how it works.
Oh, okay.
Your area
You're a
of
And
branch,
so the branch is in
so
North.
you're a branch. You're the branch vendor and Northwest is the node.
It's the node.
Not quite sure how.
It does add a
We have a
conflict.
node at Venda.
A node,
I looked yesterday.
No, yes, but it's Brea subnode.
I think that's a branch.
Yeah, it's a branch, not a.
A node, I think, because Northwest is a node for the north. And within that, they have branches, which is Venda, Mpumalanga, Limpopo.
Okay.
So I'm not sure. Yeah, I know, but that's why I don't understand how it works.
Why they should not be delivered?
You must ask.
No, but nodes and the research packages are two different things.
Okay.
Nodes run, I mean, I'm not agreeing with it. It's a
Nodes are
crazy system.
Administrative, yeah.
Yeah, more administrative. So node C, so it's not just research, because it's also all this training and other stuff.
Masonry houses.
We should try it, but
It's
just
essentially-
saying it might not work because I think it has to go through Northwest, if I understand correctly, but I might be wrong, so.
No, actually, when you fence the budget, no one else can touch it. So if this budget is assigned to borrow.
Yeah.
Yes, that's a good point.
Spend
It
it,
doesn't matter.
spend it, revert back.
Yeah.
you can have the budget to.
That's a very good point. So even if it's in the Northwest node,
Yeah.
it'll be ring fenced for this package.
Okay,
So the only hassle is you have to go and fight with the bureaucracy at Northwest
okay.
to get it.
Or you can ask the Univens administrative.
Yes,
to
transfer it. Yeah, it must be transferred to the branch.
So you could probably get it just all sent.
It's still,
No, we just.
still a learning curve. As to how to work.
I'm hearing about all this for the first time, so.
We've already managed to get this.
Very interesting.
Yeah.
Have a tea break afterwards, Barbara and Lawrence.
Was daar
I
staan?
can introduce Laura.
There we go. That's a bit. Yeah, so I think maybe just from the Mopani worms at least, I think the interesting questions, I mean, there's genetic questions, population structure and what around those type of things. Then there's a complete management process, you know, around how do you harvest, when do you harvest, where do you sell, who do you sell, which is completely informal, run by the communities themselves. There's no government involvement at all in this thing. So that's a separate component, I think. And then the other component is around where the worms are in the veld. You know, what is the impact on the ecosystem? You know, are they important? Are they not important? What happens if they disappear?
Yes.
So, you know, so I think if I can imagine ideas around projects, I can think about nutrient cycling type of stuff. You know, what do they take into the, so we got some data on that, you know, how much they eat, how much fat they produce. It's not good enough, but it's something. So we can probably look at type of that stuff, and that's probably feedback back into how much trees are produced again. So there's the things I'm thinking of. And then I think there's a big component of GIS. You know, can we, we've done one Maxent ensemble model of Mopani worms now, but it would be very good to revisit this thing and make it almost more mechanical. You know, trying to figure out, can we have better predictions, maybe more synergy between production and offtake and rainfall. I mean, these Maxent models are very simple, but you know, so those are the type of things I think fits into the Mopani.
And could we broaden our collaboration to include colleagues from Botswana and Zimbabwe, because they face very similar issues with regards to the mindful harvest and trade. And I think that everybody would gain if we had a wider geographical base.
Yeah, there's quite a lot of Zimbabwean guys who publish this on Mopani worms, also in ecology stuff. So there's definitely synergy to get those guys on board, maybe workshops and whatever to come around these topics. You know, what do we know? What can we use to model with the whatever, like almost informed type of decisions coming from modeling before we even get to data sets or maybe something like verified. But yeah, the Zimbabwe and Mozambique colleagues are important. Botswana, sorry. Mozambique, not that much. Yeah, but there is some in the Limpopo Park, but not that you know, it's not that. But I think the other one is important is that if we look at that system, Mopani worms is a big driver of the arthropods there, but there are other species that does similar things, similar defoliation, not at the same rates, but they're also doing it. So you might have 1 year defoliation by Mopani worms and another year defoliation by another species, but at lower levels. So, you know, getting maybe these ecologists on board and seeing what other species interact. So, you know, I think if I look at the Mopani worms, I would say it's an ecosystem with some key species in it, of which the Mopani worms is the top one. And I think if you go now and look at the Mopani ecosystems, they are also harvested for wood. So there's a whole wood extraction from the thing. I don't know how much that happens in other like most of Botswana. Yeah. Okay. So wood extraction is also
production. It's for building coal production.
yeah.
And there's expansion of human settlements that
Yes.
don't see value in the
Yeah.
Mopani bush.
So I think if we can start with a very simple thing around habitat now and work backwards, even just in households or expansion, you know, how much was 5 years ago, 10 years ago, 20 years ago? So do we see complete contraction of the habitat? And is this thing, is it now breaking them up? Is it patches we are seeing, you know, over the landscape? So I think that already would be a very powerful first step in the, and then this all relates to human well-being, you know, hunger or selling. So those are the two. They're always going to feed back to those two things, you know, how much people can sell for food and how much they self-consume in that area.
And then there's the basic biology,
Yeah.
that it's still not completely understood. The genes that are under selected to maintain diapause, the interactions with the environment that modulate the genes that are expressed. None of that is the diseases and pests and plagues, viruses, parasitic wasps.
Everything. Very, very little known about these things, and also what they do to support the ecosystem. I mean, remember the instar starts at 1 and goes to 5, and every one of those will feed X birds, mammals, you know, one, and then humans. So these things probably have got a massive network which we've never looked. So, you know, those are type of ecological questions we really would love to tackle, you know.
And the plant material that
Yeah.
falls on the ground without passing through the digestive system of a Mopani worm has to be different than the frass.
Yes, we've done quite a lot of that. It didn't work 100%, so we can redo all of that.
Yeah, we should talk
Yeah.
about that, because if we, one of my questions was, what would happen if we removed Mopani worms from the environment? What is actually their contribution? I don't think that is that is totally understood. And we also, so we have other people that are also interested in Mopani worms, like Alan Gardner. He's also interested in termites, and termites also play very important roles in ecosystems.
Yeah.
They are also one of my research interests, so it's a possibility if we want to also.
Well, you see, we can tackle it as an edible insect thing.
Yeah.
Or as ecosystem drivers or key species in the ecosystem. Termites and Mopani worms would be probably, in my opinion, two biggest drivers in those ecosystems. So they, you know, you can probably function it, structure it on that level. But I mean, just in one of the big things here would be just to say, over the area of Mopani worms, how much nitrogen do they put back into the soil? You know, because it's for the fresh, but it's also a large percentage of them die in the soil, so they don't re-emerge. So we don't know how much percentage that is, but I think those are all things we can model and play with and say 5% re-emerge or 20% or whatever. But that will give us a ecosystem value. You know, what is the value of Mopani worms in terms of just nutrient cycle, maybe infiltration rates? Because remember, they dig holes into the soil, you know, so they definitely aerate, help with soil aeration, infiltration rates. So, you know, those are all key mechanical things they do to the soil. And then obviously the chemical components as well.
Would you have students that could do some of these work? I mean, you'll have to do some field work.
We have to see. We got lots of students. Do they want to do stuff? I don't know. No, we can. I think around capacity in terms of if we so right now I've got maybe 1 or 2 students on Mopani worms, but more on the trade side, and then 1 on more the chemical composition of the stomachs, you know, what happens to when they eat the leaves and stuff. So trying to figure that out. But ideally, we should try to aim to get maybe a PhD or a postdoc tackling some of these things. But a fieldwork component is, I think, very important. And I think this is we should do it, in my opinion. I don't have a student right now, but we can definitely do it. It's definitely something to come up, and this is where we can design an idea around maybe 2 layers of a student.
Yeah, and also somebody that bridges.
Yeah.
Our specific.
Yeah.
Expertises. I think that I mentioned this yesterday, and I think that that's absolutely crucial to get the collaborations to work. Is to have somebody who has their head on the stake that they need to complete the study.
Yeah.
And that we can triangulate with around the research questions. So I definitely think that sharing students or supporting postdocs together would contribute to things forward.
Yeah. So I think this, if I envision it, I would think that we should try to aim for some quantitative person to do this type of stuff, the modeling and whatever, and then more an ecology community person that deals with the trades and stuff like that. Because I mean, that can build back into the model, you know, how much can be extracted and how much we think is extracted at the moment. We don't really know how much is extracted. The only data we get is when we get to the border, because even that's a guess, because the border, South African border has to record how many bags, kilos. Exactly. So we don't know how much comes over the border. We only have the real border. You know, there's a long border. So we've got no idea how much worms are actually harvested.
What I think that what we know is that for the past more than 30 years, there have been alerts or researchers pointing to a decline in availability of mobile phones. That is often, or it has been often attributed to overharvesting.
Yeah.
I think that was an oversimplification of what actually is happening to the populations. But this is a decades long issue that at least the perception is that populations are declining. I remember that I gave up doing research in the Kruger Park because I didn't know Sandra yet. And it was the reply that I got, and I think I still have that email. And the reply that I got was, we haven't seen a mopani worm in the Kruger Park in the past 5 years. So this must have been like in 2017. In the past 5 years, they told me that they hadn't seen a mopani worm in the Kruger. There was a study inside the park with mopani worms that aimed at determining concentration of heavy metals because of pollution being brought in by the
mines,
the elephants river.
rubber, yeah.
So there was, and then there was a paper from I think the 90s, and it was based on enzyme. It was not even DNA sequences; it was just an enzyme fingerprinting, something like that. But it was really difficult because sitting here in Stellenbosch without all the connections that we now I have in the areas where mopani worms actually occur, it was a very difficult learning curve. Trying to find the places where they actually pop up. So we need somebody who's boots on the ground.
Yeah, so I think I mean, if I look at the groups here, there are some nice challenges. I mean, a big challenge is, can we have the data right now? Can we actually see defoliation at that scale? Is there any imagery out there? Is there any GIS out there? I don't know. There must be something out there.
That's exactly what
Yeah.
I asked Sandra about.
But the point is, if there's no images available, can we do it? Can we get drones? Can we go and do stuff?
That's what I was thinking in terms of deliverables.
Yeah.
We try to make a low hanging fruit.
Yeah.
Almost. If we work on a review paper
Yeah.
to actually collate what is known, what is not known, and what is accessible, and you use that to generate a proposal for student. And
So that review paper is in press now. It's going to go out soon. So we've done that already. So from ecology down to whatever you can think of. So that's done in my, well, it has to get accepted. So I hope it will. Maybe that person is listening. But the thing is, we've done through all of that now, from whatever you can imagine was done in mopani worms. And I tell you right now, not even 20% of research papers on mopani worms has got anything to do with mopani worms. The rest is just people, transport, what, very little on mopani. A lot of questionnaires.
Nutritional composition, chemical composition. It's about what is the difference between mopani worms that were dried in the sun, and mopani worms that were dried.
So I think the thing that the low hanging fruit, if you know, if we can ring fence money to pay for a service, it's just to pay drones. you know, basic CSIR, wherever we can fly a drone and actually quantify defoliated areas and see if we can merge that to some type of signal out there. You know, I don't know what type of data sets are out there, but even if we can go back just 5 years in time, because it's been rapid, the changes happening in our landscapes, but I think the same thing happens in Botswana, you know, around rural development and rural growth, and wood harvesting is very big. Now, you know, from what I was just listening, I mean, Mopani worms Mopani trees is not, you know, they're very homogeneous, so you can't really see big trees and small trees, but Mopani worms don't really mind that much, you know, as long as the trees are a certain size and certain densities, they will get to them. So I imagine we might be able to detect a signal on spatial stuff here.
Have you paper, did you collate some of the data? I mean, do you know where, I mean, Barbara, you were saying that you got together a set of 23 or so sites where they were.
Yeah, but I haven't managed to convince anybody with skills in satellite imagery to help me figure out
If that's why I think
if there's any signal at those sites.
if we have those coordinates, there are.
Yeah, we can talk again about this.
Because
I've all the
satellites.
all the studies that we found, we put the GPS point to them, you know, but like I say, 90% of them are questionnaires done by a researcher sitting in Pretoria there. They're coming from Mozambique or Botswana. But anyway, I got all the data sets, all the GPS data for any ecological study that's out there.
So
But
that's
what's-
maybe the next step is to
Yeah.
look at where are known defoliations, because there's also, at least within Kruger and some outside, there's LiDAR data. So that's going
And-
to give you structure.
and-
as well as
and-
foliage.
Yeah, in Kruger, you know, Tony
Swena.
they have collected a little bit of Mopani worm data at Palabora, that area. And he sent me some data sets some time ago. So there's something, it's very small scale, but there is something there. So I think you're right. We have to collect whatever we can right now in GPS points.
But I have it.
From Tony.
Yes,
Yeah.
it was quite, so we had this meeting organized by Ruan, by Sandy. Because the idea was that we became a work group to work on the, what's it called? The,
Edible insects.
no, they have a name for it. It's a revision that they do every year.
Oh, yes, it's for the-
Diversity assessment.
Yeah, conservation assessment.
Yes, it's.
Red listing.
biodiversity assessment. So we had that one meeting once, but I think it was not enough for people to bond so that they work together. And I had already met Lawrence, so there was more affinity than with the people that I hadn't met. But I used that opportunity ask Tony because he usually had data. So I think that those maybe 12 points that I have that come from his research, because the idea was, are we able to discriminate these points? All the surrounding areas, because then we would have maybe identified a signal that we could test throughout the potential distribution of the species. So we would see the outbreaks flare up throughout time and space as we would detected them. I think that this is a huge part of the
If you look at the outbreaks in South Africa, the outbreaks is not very big, so I don't think we'll get them on a signal. But in Botswana, they're huge. They can be 50, 60 kilometers.
That's why we need to. We need to collaborate with the colleagues from Botswana.
Yeah. So Botswana.
Anything like
Yeah.
that.
So Botswana is. I mean, I've never seen it at that scale, but people say if you drive on the road, there's just wind. So it still happens there, but
It's in Kruger. I mean, I've driven through it sometimes, and you can hear them.
yeah, you can hear them.
You close your eyes and you know, and you look, and there's no foliage anywhere.
So that's what I mean. So if we can look at that, because that gives you an idea of scale at biomass. If you see a 50-kilometer defoliation, you're probably going to sit on excess of 1 million worms. So it's huge. So that thing is even.
The Kruger part, have that type of data.
So I put you into, remember I put you into contact with Hendrik Sutole? He's the SAMPOX entomologist. So we must maybe revisit that. So we started a project. I started it with him many years ago, and we had some data, but it wasn't GPS locations, it was blocks. So ranges, we've got burn blocks, which are managed. So then there's a list of which burn blocks had outbursts each years, and then they gave dates for those.
I think that the hurdle was that he had to ask somebody for authorization to share that data, and then we just.
We must revisit that, but
We should.
I think what's going to be the we can now detect that pattern from a
Yeah.
higher resolution. That will then you can monitor.
Exactly.
Maybe
Okay. Say even the Kruger ones, I've asked many years also for cyber tracker data to ask did they record on cyber tracker for Mopani worms if they see them, but you know, yeah, that's before I met you as well, because Kruger has been a black box to all of us. But the it works, but I agree with Barbara, it's for us key to get Botswana and the Zimbabwe guys involved, because maybe they have data sets, because I know they gain I've not seen anything. All papers coming out is normally about consumption, chemical quality, questionnaires. Yeah,
Children.
yeah,
But I mean, they value the Mopani worm a lot, to the
Yeah.
point that in South Africa, we have the walkies in our rent points. They have the Mopani worm.
Mm.
Also because a lot of people who do research in the conventional scientific way have some kind of yucky reaction to any reference to edible insects. So that contributes to a divide.
The other component that I see with this Mopani worms, you know, that comes back to the biodiversity side, is there's definitely a need, in my opinion, to also look at what other diversity sits in that ecosystems. Because if that system is protected for harvest and for the Mopani worms to actually do their job and produce food, you know, what else are protected? You know, how much, I mean, people think Mopani areas are poor, you know, biodiversity-wise, but we don't really.
Published it recently on exactly that, but with vegetation, and actually the herbaceous layer was more diverse
In Kruger. Okay, so you see now we have to go out.
Camera Trap project also,
Yeah.
more species there.
The changes a bit with grazing of the livestock and whatever. But anyway, that's the point to actually also to look at, because we can, yeah, if you go to Kruger data, we know technically what can be supported by Mopani woodlands, and then we can even compare that to utilized landscapes. That's another important thing. The other thing I think is important, if you look at Mopani worms, these are explosive populations.
Yes, outbreak.
But if you get Mopani worms outbreak, there's a high likelihood you'll also get Quelea outbreaks. So you have Aquarius,
It's a
the
big-
birds.
Oh, there's
When,
But you see, those things also sometimes work in a synergy. Or not synergy, they're in this, so the habitat is good, the environment is good. So, if you look at those type of things, you go from maybe 1,000 animals per hectare to hundreds of thousands.
explosion and abundance, and then it may retract.
And it retracts. So they obviously cycle quite a lot of nutrients back into the. So, I think if we look at Mopani worms from a nutrient driver almost or a cyclone, there's going to be other species sitting also with Mopani worms in that same thing. Same thing with rodents, probably. A lot of the rodent species will go through a boom in that same time as well. But we don't know.
Yeah, and from the
Chickens.
population genetics perspective, this is super interesting, because what you have is a succession of bottlenecks.
Yeah.
You have population
Ocean.
variations, and then bottlenecks.
Yeah.
So you have a permanent subsampling of the populations throughout time.
Yeah.
That it has to drive, it has to
Yeah.
drive a decrease in genetic
Diversity, yeah, that's what I was
Because
for.
you have a succession of bottlenecks.
So, I mean, those are the things I come from my mind now that I think we can do, or what we want to do. if we
And this
can.
is interesting because, because the canonical view on genetic diversity is that the highest the better. But that's actually not what we see in a lot of species. What we see is that the populations may expand from a very small number of individuals. And in the wild, they seem to be fine.
Mm.
I think that it's because the ones that are not fine are naturally
Remove.
removed from the breeding pool. Challenging, interesting, and it feeds into human societies, into ecosystems, into biodiversity per se.
Yeah, so that's what we,
And the area is actually huge.
yeah, it's big, very big areas.
Just practically you speaking. I think there is three products. One is a system model to include all the players. I mean, worms, birds, all sorts of things. In a spatially implicit system model. So it's a set of equations. So essentially what we need is experts draw the diagram. Network of graphs. We don't need the rates, everything.
Yeah.
We just need a diagram. To include all the players. Yeah. So that's one product I'm thinking. So it's a system modeling and we can explore outbreaks, dynamic behaviors.
So basically,
all those
we want a diagram of the savanna woodland, including all the species
That we think impacts or they move between, potentially, yeah. Yeah.
I think for that direct interaction, actually, there are lots of experts can give very accurate estimates.
Yeah.
But it's kind of, I mean, compile that into a diagram with potential rates.
Yeah.
The set of ingredients, then we can study the system, dynamic behaviors, abilities, outbreaks, forecasting, handling cycles and so on. And when you interpret that as algorithms and so on, and you can test it. And so that's one product I'm thinking. So typically when they like defoliation by insects, they're testing using fixed wing. I'm not sure satellite image is high resolution now. Well, definitely is fine.
spectral data
Yeah.
that's tuned for defoliation by Because the presence of the Mopani wolves, it's not just the population.
Mm.
It's the presence of a huge amount of frass.
Mm.
So if you can use drones and spectral imagery to assess maturity of grapes and nutrient deficiency in grapevines, you should be able to tune it to this type of thing as well.
Okay, so the second product is this. If you can mobilize local collaborators, data providers to get the GPS records and the timestamp of it.
Yeah.
So it's X, Y, and time. And
Yeah.
to a Excel sheet.
Yeah.
And then we will try to match that with,
Yeah.
because there are lots of new developments.
Yeah, yeah.
The resolution can be extremely high.
Mm.
The polar, what is it, Alpha Earth, 10 meters.
Yeah. Yeah.
Sometimes we don't care about what each layer represents.
Mm.
Satellite embedding.
10
Yeah.
meters,
Yeah,
is that high?
no,
Okay.
10-meter resolution.
So 10 meters is 1 pixel, so it would still have to be
But it's considered high resolution 10 meters.
well, hyper free.
It's very high.
Hyper free.
And it's 64 layers.
Mm.
We don't know which layer.
But yeah,
represents,
yeah.
But if we have the coordinates plus time.
Yeah. So that would be, yeah. So I think that would be for that product, we'll probably have to make sure this year that we put a lot of effort with our, so now we have to get to some Zimbabwe colleagues, Botswana colleagues in,
Casper,
yeah,
he's.
yeah.
I can trust him with.
Yeah, so but that's I think, and then in Kruger, whoever can monitor there, and then other parks, Vidisha, Mapungubwe, I mean Kruger, some parks can also monitor Mapungubwe, but that would be so. But what's important here is that you can. What we should really try to get from that people is outbreak data, but also areas where there's no outbreaks. So now, if we just get positives, there will be a shitload of Mopani trees on that side with no Mopani worms. So we need to somehow get,
Who knows all that? It's the harvesters.
yeah,
They know all that.
Yeah.
And I'm sure that they have some kind of memory or records. But sharing that information.
yeah. Well, the harvesters is one. There's another. I think for me that would be another web package to tackle that side of it.
Your system knowledge.
Yeah, yeah.
Check how harvesters affecting the behavior.
No, that absolutely, they have to be part of that diagram in parts of the distribution of the Mopani code.
I think the thing that I wanted to ask you, Dick, on is, so we just made like a maximum model of Mopani worms, right? Using Mopani trees and soil and water and what. But I was thinking, can we do one for Mopani trees? But not, maybe combining, like a Maxent type of a distribution model, but with real data, like spectral data from Mopani trees itself.
Understand the phonology.
Yeah,
That's a Miombo project, Sally Archibald. That's a lot of that.
Because every time I need a map with an updated distribution of the Mopani woodlands, I cannot find it. I mean, there's stuff with very low resolution from
It's like-
years ago that showed the map of Africa with like a.
but there are two maps of Mopani trees in the country available now that you can download. And both of them are Maxent, and then the other ones that people draw with their hands, But so definitely the Mopani tree is also a very important parameter we have to somehow estimate.
Yeah.
And I was wondering if, there's definitely two Maxent models of Mopani trees. One that was the climate model where but the thing is that there was actually a big paper on Maxent and Mopani worms and the interaction with the species. Did you see that one? It was a few years ago. I was in the review as well. But anyway, so in that model, they quantified how much Mopani, where the habitat is, and what Mopani worms will be based on other things. Yeah. Anyway, but Mopani trees itself is still a parameter to estimate, in my opinion.
Yeah, we'll step into that.
Bernard, you know, I'm sure Sally Archibald did some work on the party, and I remember seeing a higher resolution map, but I think a lot of the time our problems are we don't know where the data is. It's
Yeah.
sometimes it's even published, but it's just so much to get through to figure out where it is.
There are data,
So
but there are the gatekeepers.
But sometimes it's not even the gatekeeper. Sometimes we just can't find it because.
But so you can see Mopani trees is a key variable to have because
It's all the games.
yeah, if the Mopani trees decline, then obviously the worms will decline. So we need to know what happens to the trees as well.
Principle, we can do that.
Yeah.
So all we need is X, Y, and the tree phenology.
Yeah. Okay. Yeah. Mopani, yeah.
I
Take
can-
them off.
Yeah.
The life cycle.
Okay.
I can get in touch with Casper and if he doesn't know in Botswana where that data might exist, he will know who could know.
Yeah. No,
Judith online actually has a comment. I don't know if Judith can hear me, but say on the mic.
Yeah, we can hear, we can hear.
Yeah, we can hear you.
Thanks, Sandra. Yes, can I go ahead?
Please go ahead.
So colleagues, I've been hearing a lot of conversation this morning around, SANParks and the difficulty of getting data from SANParks, Kruger in particular, but some of the other reserves. And so I just posted something in the chat there to saying that we really aren't adverse to sharing data with colleagues, working on different types of projects. However, we do have some processes in place that need to be followed, and it's not because we're not trying to share our data. It's just that we want return on our data, but also we're very interested in the products that come out. And in many cases, when we give data, or if data is used without us being part of the process, we don't have any inputs in the first place, and we also don't know what products are coming out of it. And I think this is going back to what Sandra's also been going on about in the last 2 days, about having ecologists on board and having people actually part of the collaboration that know that particular ecosystem and can actually give good comments, so that it's not just a modeling exercise, but that it does answer certain management questions that we might have, as well as some of the other questions. So, we do have a project registration process that we go through in many cases to get some of these collaborations registered. So please, if you are interested in using some of the data, I have been listening to this Mopani worm conversation. I'm not really a Mopani worm expert, but I think some of the more specific tree data that's being alluded to is probably very fine scale, and we might not have that. But you guys are welcome to reach out to me after the meeting if you are interested in something, and I can then either help you myself or put you in contact with, as Sandra mentioned, Hendrik, who is our entomologist in SANParks. So that's just, I think, from a SANParks data perspective. Thanks.
And there's also the BIMS system that you guys developed, Judith. Last year, I think it went live, that you can explore what data is available. I think you have to log in though.
So the BIMS system is the Biodiversity Information Management System. And so what we're trying to do is we are trying to get a central location for species data. So we pull a lot of data from other platforms like GBIF, INAT, and some various other platforms as well. And we try and get as much species data into the system as possible. So our own data, and then any data that we're aware of from publications. So to try and give us a better idea of what's happening with our species in the park. Unfortunately, quite a bit of that data is lead time protected, so it's not open publicly. But you guys are also welcome to explore that system. But if there is something specific that you're looking for, you're welcome to email me, and we can see how we can take that forward. Thanks.
Thank you, Judith. Appreciate it. Thank you.
Yeah, I think importantly, even if you can't access the data, it has the metadata, so you'll know who to speak to and what is available.
So it's the
BIMS,
BIMS.
BIMS.org, I think.
So the third activity I'm thinking,
Thanks, Judith.
does the planning work out like file all time as well?
What's it have?
Sorry, can't hear you.
It depends. It may depend, so in Namibia. It depends on the year. The good years, with good rain years, it will have like a December and a March generation. Bad years may have only one generation or zero generation.
Zero, yeah.
I actually don't know, and I don't think anybody knows if the March generation is actually the progeny of the December generation, or if it's the progeny of the March generation of the previous year.
Yes, yeah.
So I'm not sure about this. If they actually do this,
Yeah,
or if they do this. If the March generation and December generation are reproductively
Separate.
separate.
So there's, on average, when there's a good year, there's always a December and a March. But on bad years, you might get only a December or only a March. And then in some years, you get nothing.
it's a brilliant system to study insect botanism.
No.
Explanation genome of icons.
And we can easily now acquire methylation data.
Yeah.
So methylation means which genes are active or which genes actively expressed and which genes are not actively expressed. So we have that layer of information of gene expression that's super important.
Also, can we do a epigenetics of
We could, and we can do that with the data that I already have, but it's only one individual. So I would have to sequence more individuals from different.
This is still recorded, but how much does it cost to have one in it?
This one was cheap because I got a huge discount for the long read data.
So is it possible for us to sequence
Yes.
the
So
whole population with somebody?
what needs to happen, but that's why we need boots on the ground and we need to react very quickly because last year when I went to the Savannah conference, the Savannah conference was one of the objectives, but my main objective was to, after the conference, to go to Limpopo and bring back live Mopani worms. Because there was no way I was going to be able to extract and preserve the DNA and the quality and amount in somewhere in Limpopo where you don't have a DNA lab, you don't even have a DNA lab anymore.
We have many. We don't use them.
So I drove back with a box of Mopani worms, feeding in a box. And that's how it needs to be done. And you can't fly, they appear, somebody needs to drive them to where the DNA is going to be extracted and sequenced. And that's how we got such a high quality genome that's almost chromosome level assembly. Because somebody drove them and brought them back alive. And there's no way around this. So the logistics can be a bit. Somebody needs to get in the car and do it.
Yeah, we just published a mathematical model to explain adaptive strategies in insect botanism. So the univortan can change to bivortan in the system. And of course, the model have lots of parameters. For us, it's just sensitivity type analysis. But if you can identify maybe two populations.
Actually, this one, the one that we sequence now, it's the March generation because, we consider it the March generation because it was at the time of the Savannah Network meeting last year, it was the end of February, I think. So that was the March generation. But the place where I got them, they're happy to collaborate and it's safe and But
No,
it may happen that they just don't, that my first year with this project, I could do zero work. Because it was a terrible drought year and there were no mobile homes anywhere. So I had to explain to the NRF, I just think I'll find
Yeah.
them.
No, I mean, to get the worms is, you know, our issue has always been the collaboration side of this stuff, because I mean, we can collect them fairly simple from where I live. It's just, we need to decide what to do with this stuff.
Yeah.
So that's the question.
So we can sequence the different generation from the same spot. The December and March generation,
Yeah.
and pray that there is a December and a March generation.
So what do you think, Inkan? Do you think different populations, different areas?
Because if there are variations in terms of
Yeah.
some areas that just that population under the same tree, but
Yeah.
they just have one generation. 2 generations, you can, of course, we can track every month.
Yeah.
That's something that we can geosee the scene. And we can check the epigenetics and see what is responsible for.
Yeah.
Stages.
Yeah, so you see, I mean, this makes it such an interesting species to work with, because you can have a tree here. And this year there can be an outbreak here. But next year will be nothing here, but it will be just there. And then year 3, it will be there. And this has always been a question. Is this group, is it family now here, or, you know, how is this thing structured? And then you're talking about maybe 100 or 200 meters, but now what about kilometers?
Yeah.
So you see the same thing happening at kilometer levels, and then you can even cross the boundary now. And then, you know, then you also have scenarios where I say, you know, they get pushed into suboptimal habitat. So that they're blown away and they get to difficult habitat. So you get lots of worms, but they dig in, they might get 1 or 2 out, but they're not in the good habitat. So this thing is doomed for extinction. But it doesn't mean it was because of that. It's because they're just not in the right habitat. So yeah, there are so many questions around the species on the ground.
And then genetically, it's actually a good, we're in a good place because there's lots of, the silkworm has been studied to exhaustion.
Yeah.
So all these questions around what sort of botanism.
Yeah. Competition and
Yes.
lots of things can trigger that, change the.
Yeah.
So there's lots of studies that we can use to compare the patterns that we find with the species that has been through a domestication process.
Yeah, you know, there are so many things to, I mean, we've done a little bit of playing with this stuff. The question is, why do they emerge? Is it soil moisture? Is it soil chemicals? So, you know, even just getting them, transplanting them into and just putting water on, you know, to see if they emerge. So we've done a little bit of that, playing with it. It's just playing, you know, it's no real science. But, you know, there's all of these things that we've tried to think, why do they do this? You know, why do they, because they'll say the communities will tell you, the stuff is right, it's going to come now.
Yeah.
You know, they will even, some of them WhatsApp me and say, it's going to come, do you want worms or something, you know, because I used to pay them for worms. So, and then lo and behold, a week later, they will tell me, they're here, you can come and harvest. So they definitely see the signs. So there's probably, but we don't have a lot of info around what the decisions the worms are making. And this is the key thing. You can have a huge outbreak here, and next year, nothing. Not a single emergence. So we don't know if they are dead. I mean, we dug up and see how many are dead and stuff, but, you know, so there's a lot of other questions to answer.
Yeah. I think that those type of basic biology questions, you know, we actually have dealt with before, but we're not using the part of words.
Yeah.
Chip the north.
Yeah.
They're defoliating the trees in northeast US.
Yeah.
They have fixed wing surveys.
Yeah.
So they infer the abundance, we can see.
Yeah.
There are lots of interesting things that is completely not biology. It's so they can synchronize in the emergence, or the desynchronized, what you said, the stream.
Yeah.
Emerged this year, That one makes.
Yeah.
Yeah, because they have a very small,
Yeah.
Thanks.
they
Yeah.
have a very small window to do their business. They cannot feed properly, so, they must find a mate.
Hmm.
And then their life,
Just ended.
that's basically their life accomplishment. People only live for 3-5 days.
Yeah, it's very, very, once they lay the eggs, they're dead.
So coordinated, so that's a missed opportunity, so they have to somehow be coordinated.
Yeah.
They need to be on the wing.
Yeah,
or
when
at
once the
same time.
females are out, the males must be there.
Yeah.
Yeah,
Yeah.
not just the worms.
Yeah, yeah. Yeah,
And so what I'm seeing is 3 activities.
Yeah,
That
3.
is like
Yeah.
seeds for each activity.
yeah,
One is system modeling,
Mhm.
which is a set of differential equations
Mm.
that we have to need expert knowledge
Mm.
of which one is affecting which.
yeah,
It will include the life cycles of the species.
Yeah.
And if you want to also include tree theology,
Mm.
that's also need to be included.
Yeah.
And then we can, so that model potentially can explain outbreaks or cycles. It's not annual, it could be multiple years for that cycles. And the model can also potentially mathematically explain buy more time strategies or using more time. And what are the triggers, how harvesting is affecting
Mm.
the change of life history strategies.
Mm.
So that's one thing. The second thing is detection.
Yeah.
And
Yeah.
we don't have budget for fixed wing, but we could have
We
like
can-
flying drones, eh?
We
Yeah.
can experiment first with the higher resolution.
yeah,
Imagery that we
If you
have.
in your secret agents in the field. That, so they know that it's going to happen
Mm.
before.
exactly, yeah,
Before it happens.
happens, yeah,
So they're seeing something.
Mm.
Right, and if you got imagery from that place where they see something and follow it.
Mm.
Through time, and maybe we could see what's actually happening.
yeah,
It's not just the imagery, but I think that maybe that's your third one, is actually the drivers behind it. So the one is detection, which is just looking for a pattern. The other is looking for what drives it.
Yeah.
There's a trigger. Some sort
Exactly.
of trigger that creates
Yeah.
this, makes this
Yeah.
outbreak
so I
start.
think that's where we,
Trigger.
like in Kruger, I mean, I don't know if there's going to be weather stations nearby or what is going to be available. Venetia Reserve and Mapungubwe, they always have outbreaks, but asynchronous, and they have weather data. So that would be key sites to go to and say, we need weather data. And those guys, like I said, I used to pay them to look for Mopani worms. I can just ask them again to do it.
That's what
Yeah,
I see. That's
Yeah.
Venetia.
yeah. So those are sites that can give us, in my opinion, good ground. Well, if there's worms this year, but good ground truth data. But then talking to Casper and these guys from other countries is to see we need some weather data if we can close by wherever we can detect. And even if we get no worms through that cycle, we need that point to say that the defoliation was really good, but there were no outbreak. And this is the parameters that was there, given the other side that we had an outbreak or whatever.
Yeah, so the second one is basically you have to compile GPS coordinates
Yeah.
and time.
Time, yeah,
And the description of the
Yeah.
events.
Yeah.
It's outbreak or it's defoliation.
Yeah.
And phenology or.
Yeah.
Which things are the more.
Yeah.
And then we'll see.
Yeah, so as soon as we have that, then we can decide what we can get.
Yeah.
So then
Yeah.
in terms of where those are, we can find out which is the closest weather station.
Yeah.
And see what's the detailed data that we can get from that. And my guess is we will have to take those local data and tweak some of the global models so that you can have a surface of temperature and a surface of rainfall.
Yes,
And there's also some really good soil moisture products now
Yeah.
that are low resolution, but they work really well, which is
Yeah.
quite surprising. So the first step is just to know where we must look.
Yeah.
Which has always been the problem, like you said, because we don't know where it's gonna be next year.
Yeah,
But if we're looking at in the past and you know those coordinates, we start with that and then
Yeah.
see what we can do. This week.
I mean, we can also look towards the future and say, can we target some sites? Where we put a weather station down with salt probes and hope and pray that comes on the uptake. Or we can even put worms there, or, you know, you can transport worms. It's no brainer. I mean, if we put a probe here, we can bring 1,000 worms here. And they will be raised here, some will survive and they will dig in. So we can probably do some experiments, but those are different things we can do, which will inform better modeling in future. But we probably can think about, you know, now I think about too much stuff to do, but, you know, maybe that would be a future project to do.
How many species of caterpillars of Saturniidae are harvested and consumed?
Yeah.
From that I know of, from Kenya southwards, including West and Central Africa. It's a huge
A
number,
lot.
and it follows more or less the same principles.
It's the same idea.
It's it's moths.
Moths?
They deposit eggs, the caterpillars emerge, they eat voraciously, they do a lot of frass.
Yeah.
So they must have an impact on the ecosystem. Everybody feeds on it, including you. So this is the Brazil story. It is repeated across the continent, basically throughout most of sub-Saharan Africa that we know of. And every time that you go and look a little bit closer, you find that communities are actually actively doing this, and they are utilizing species that you didn't even know of. So there's a whole network of knowledge and activities that we are not considering, that we have been very ignorant about. I think that in terms of this type of caterpillar, it's a huge number of species. I can look at the compilation that I did a couple of years ago. It's huge, and every community will harvest the species that are most abundant, obviously.
Yeah.
And the ones that they may have a preference. For instance, in Namibia, the community that harvests this species because it's very abundant, but they don't appreciate it, and they trade it with another community. And in Namibia, it's the green one, the squidgy one. In Malawi, it's actually a very scary looking caterpillar, but it's black with white spikes and red dots. And that's the one that they harvest and consume the most in massive quantities. Up to Kenya, at least.
It's the same story. The edible insects is very similar around. So, you know, if you do it here, it's the same thing and that might be the next level, to upscale it all the way through the distribution of these species, you know, because I don't think those ones are traded as heavily as ours. I don't know. I'm speaking under correction here, but it will probably come in future. The trade is probably going to increase, you know, with time. So it's a good model to work from, you know, in terms of human consumption, but also in terms of ecosystem.
I like big areas.
But I think at least the sample collection.
Yeah, but I've already sort of established relationships with researchers in Namibia, for instance. So I mean, if we need a research station there, and there's somebody who's super interested in this and who can offer a place that's safe, where we can plant a couple of things. And it's just happened by accident. It never happened, such as the relationship with Benicia, which is a bit more distant because I don't know the people directly. But this stuff that we can do. And Casper in Botswana, he's an invaluable contact for us to be able to include a transnational component. And as we heard yesterday, NITEX is Africa.
Mm.
It's not South Africa, it's Africa. So our neighbors have
Mm.
similar ecosystems and similar interests, so we should.
Yeah, I think
should
if we take those three ideas, put them down, and we, put them into some structure that we can talk to other people and say, this is what we envision, are you interested? Because that's always been the Mopani has always been a stop-start, it's one of those things. There are millions now, then next year is nothing, then everybody lose interest, and then we start from scratch. So if we have a unified view now where we can do stuff, I think, this would probably be, I'm going to say it, revitalized us in doing something. There are many, many more questions, but I mean, this ones I think is very good to start off.
And I already read in the genetics of the Mopani worms that gives me a little bit of credibility to ask for more support.
Yeah, I think what I think here is that one of the key things would be to say from your guys' side is, can we identify potential candidates as PhDs or postdocs? Because even from us, the Sarchi chair can probably support a postdoc and this type of stuff. If we have candidates that's sitting out there. So I think that would be the key thing is, like, can we identify people who wants to get involved and do this type of thing, and then in the meantime we'll try to get the other stakeholders on the ground in partnerships, and then whatever data we have, any GPS points we have, things that we can put onto maps right now and see what's out there. And then I think key sites like Venetia, Mapungubwe, Kruger, where we know outbreaks occur and we can get some very fine scale resolution there. That's sites we should target in terms, even if we have to put weather stations up there now, to see if we can at least get some good ground truthing data sets. So I think that's the low hanging fruits at the moment. It doesn't take a lot of investment to do that.
PhD students, or not the problem, the challenge is that it's a long-term investment for them, right? And if we can't offer a fellowship, how can we expect somebody to work full-time towards a long-term objective that has very little short-term reward or gratification that makes them tackle really difficult problems, and they have to put their whole life on hold for a few years, and how can we support them? So that has become a massive challenge now, because we're getting more and more part-time students, but part-time students, a lot of their mind space is allocated to basically making a living and carrying on with their lives. So it has happened to me that I identified the person, and then the fellowship didn't come through, and the person decided I can't do this because it's just too much having a full-time job and doing this on the side. So that's from my side in genetics. This is the prospect. Maybe where you are, they can have part-time jobs that they can run that are part of the project at the same time. I don't know.
Well, yeah, the bursaries can't be allocated if you work anyway. So for us, the biggest challenge normally would be the resource to do the work, like vehicles. I don't have a dedicated vehicle I can give to somebody to go to the field for 2 months and do stuff. But I think, from the fellowship type of person, a postdoc, a lot of this stuff is going to be computer work. So that will be the first entry, in my opinion. And then from there, I think we have to think carefully around applying.
That I can ensure.
What?
Well, I'm the process of recruiting one. I can allocate.
Okay, but then I think that's the first step. But the second one is also to look for funding at different options, to say, can we dedicate one person for 3 years, in terms of more on the ground level, like trying to get these signals and things like that. But the postdoc type of person really pushes the other stuff that we can get output from, but doesn't need that much groundwork at the moment. So that's probably the two things I think, you know, to tackle.
That's not what I said in the advert, but I can tell them that this is not what I said, but this is what's going to happen now.
The farmer's perspective,
Yes,
post on,
yes,
and sample at different times per years.
yes.
And do.
So let me start. Is it the postdoc?
It's postdoc.
Gene
It's
responsible
postdoc.
for the new stars, for dipoles, for
Yeah.
everything.
We wouldn't have to deal with proposals and theses and defenses and all that. We could be more efficient in.
Yeah, but that's, I mean, that's the key first strategy then, you know, if we can get that to run and like you say, you know, sample and, you know, you can think about Kruger or we can think Venetia, but it doesn't matter. We have to think of that landscape because it's going to happen there somewhere. We have to be ready for that person to drive and sample. Even if in Kruger it happens and we can pay somebody, arranges or somebody to just go through the sequence for us, that we even have multiple of these things happening. That postdoc have to coordinate this stuff. You know?
Somebody needs to make a phone call and somebody needs to drive there and bring back the worms for sequencing in a box with plenty of food and they.
Yeah, I think this stuff is is all possible. We can, if you have that person in line, well, let's, you know, we don't want to say too much on telly here, but if it's there, we have some time until the next outbreak will come. And this has been a good year. So hopefully there is somewhere a system.
Until December.
Yeah, but they can do stuff like papers.
You're just using your review paper.
Yeah.
You can start thinking about the whole process and what's missing and what needs to be
I
done.
think they're going to be enrolled for Mopanimum genomics.
Oh,
But that's what they.
Well, there's just some of that.
They need to have a rude awakening. I don't even know who they are yet. But we can work with that because
as long as they can drive, they got driver's licenses.
and to tell you the truth, I'm very eager to work beyond the boundaries of what genes do and ACs and Ts and Gs and.
But so in the work packages, so if we say now we're going to do something and there's a budget we can allocate, is there a budget that we can pay services?
Services,
That's
yes,
where.
but not equipment.
No, but I mean
Not
services.
people.
Yeah, I want to pay somebody to do things.
Yeah, but you have to lie about what it is.
That's fine. I'm not.
No.
You're just getting a service.
Yeah, no, a service. So I can pay somebody for a service.
But they can't be a student
And that's fine.
system.
You can top up students.
So I was going to say,
But-
but you can top up students.
Yeah, but you can pay somebody. So I can basically pay a technical person to do X for me.
That person is providing the service.
Yes.
Yeah. You can't send a thing through, I'm paying this person.
No, I'm just thinking if you can pay somebody, like you're saying, collecting stuff, very simple. We hire a technician. And that person drives around and they just collect on different stages.
That should be fine, yeah?
Well, that's what we
Think
put
so.
in our budget.
Yeah, so that's a service. That's
Yeah.
technically somebody is collecting data. Because then,
How we use that.
yes. Because that's not impossible to do because you won't believe it. Some of my students, they do sell Mopani worms. They try it in it. So if I just tell them, listen, mates, you're going to go to the field. I want all the installs and I want at least 4 sites.
Expensive.
Hmm.
It's really expensive.
Hmm.
That my incursion to to Venetia to kidnap them was very expensive.
Well, the diesel is now 50 rand a liter, so it's going to become even more. Hmm. But so if we can do that will already help quite a bit because then you can already identify somebody, get a agreement in place, and then start to scout for sites, and that's the service they give us. They give us the
You just have to register on the administration system. So like here, Sunfin, you have to be a registered vendor.
vendor.
So it has to probably, I don't think it can be a person, it has to be a company.
Can we pay?
No,
for
it's fine. It's fine, but remember,
Yeah.
we have to, whoever is in charge of this thing have to remember we work in Africa and we work with small enterprises, one man shows. So we can't divert all the money to the big companies out there.
So it can be sole proprietors.
Yeah, but that's why I'm
That's if it's Stellenbosch. Am I right?
So I don't know about the other nodes, but I'm.
Yeah, I mean,
But I don't.
it's UT, where am I? UKZN, we're making it up as we go along.
So can you pay, you don't have to put an individual on as a vendor. How do you pay someone first?
Here it's a bunch now, if it's a person, an individual, they need to have to be, have a tax number with
Yeah.
SARS.
Yeah.
So,
So for Stellenbosch, I know how it works. But now you're saying it doesn't work that way.
Well, we don't know what we're doing, but what we've done is we're getting the hydrology department to curate. This is the new thing, curate clean existing data and provide it for us. And all we've done is, exactly.
So if we do something like this, so this person is going to be paid for Potchefstroom technically then? So we have to be registering.
We have to find out.
That's we have to
about
find
load
out.
Administration, so
It would be good if we can register them at the Univen, but Venda University, that's much more easier.
You can't work. You need to discuss with the main representative.
Yeah, okay.
Thanks.
So I think at the end of this meeting, we
Yeah.
need to know exactly what everybody needs.
Exactly.
So that we can explicitly ask. This is what we need,
Yeah.
and how can we do this? Is it gonna go to the node and then you get all the money
Yeah.
there and then you distribute
Exactly.
it? Or do you have to have a vendor registered, I don't
Okay,
know.
so that's what we need to figure out because we've got time, until this stuff starts in December, or November. So if we can get this all sorted out and get a person in place, then we have,
I'm quite part of it.
okay, I think that's it then.
Okay.
We're gonna have lunch break and then we. Carlos, are you talking to?
We're gonna discuss where he is.
I still don't know how I ended up. Yeah, but
Yes, but that is part of it.
Animal movement.
Yes, but I think that is part of the discussion. I would want to see if I can fit my activities in another work package.
So we have lunch break and then for 1 hour, something.
We probably need you.
Well described, you know, if you read in the background, figure out what they.
Yeah, I think it's already.
Stir the pot.
Yeah.
Are we all clear what we're gonna do in the different work packages? Which work package we haven't covered? Kevin, we want to give a short introduction of work package 5.
Okay. Because 4 months later was abandoned.
So for currently, there is no person gonna do it. The initial idea is animal movement modeling. Katharina doesn't have time to run that. We have a number of students working on that. We don't know, because we are using data through collaborations, through projects in some parks and other places. We are not the data owner. So we can't open up the project to say, everyone come to analyze the data. But if it's MoveBank data, like an open access data, of course, we can work together on those things. This year, I suspect we will not propose any activities. And so the budget was basically, we're gonna see, like, when you write your items, you can just put your numbers, but the total number is 700K.
So you're saying we split it between 4 instead of 5?
It depends on your activities. The thing is, you can over budget for your activity, but then there's deliverables and so on.
But I mean, it's how long is a piece of string? Everyone, everyone could spend more than this developer, I'm sure.
Yeah, everyone can spend a little bit more, but according to our experience this year, Kevin also had the idea. We have the budget, but we can't get it.
Yeah, but that's gonna change.
Yeah, I said,
We're starting early.
I know, but it keeps saying that, but we still, in practical terms, we still can't easily get through. I mean, yesterday, Francesco mentioned that they will design a platform. Design a platform you can use a platform to access your fund, and I don't know how long that's gonna take. So in practical terms, the work package 4 this year, we're not having any activity. I mean, at least it's from METAC's point. So, but maybe from Masachi grant, we want to support the workshops. I will still invite some folks. But from METAC's point of view, we don't have capacity to run it. Yeah. Carlos will also think about research activities around agriculture, digital agriculture, and he will also invite, especially if you are theoreticians, modelers, can contribute to his data analysis and so on. But when you are ready, you can share with us. Yeah.
And he's also welcome to join in. On
Yeah.
In presenting.
So what I'm saying is the work package is not a hard boundary. Everyone, you can see where you fit the best. Yeah. And it's just, if I have this small pocket of money, then whoever can, I shouldn't say whoever can access it, get it, but we were struggling to get it, okay? Even though it's ring-fenced for us. I mean, Sandra, Priyanka, a number of us have tried in 2025, but we're struggling to get it, yeah. Matlu, do you have any activity that you would like to propose?
Yeah, I would like to propose an activity, but I'll need to sit down and finalize it. So
Okay.
my question was actually, so the 2026 work packages cannot be added. We're gonna stick to those work packages. I can only join a work package.
Well, we can, you can say work package 4 is a all inclusive, but it's without a definite topic at the moment.
I think also the work packages on, even in work package 1, we have different themes. Those were formed in an environment where we had lots of different people working on a lot of different things. As the packages are getting smaller, those themes, a lot of them overlap. It's not in stone that that's the name of the theme. So work package 1 is complex ecological complexity and biodiversity, everything. So you have an idea, just adapt to it. It doesn't have to fit into one of those specific themes. Even though I didn't mention game theory, for example, it can fit there.
I hold this as well.
Flip it on.
So, good afternoon. I'm completely overwhelmed. And I have to say, work package 5 now feels exceedingly boring compared to everything I've heard. But so this is what I want to start by saying, and we all know this, every model's wrong, and the bigger the model, the more likely it is wrong. But without doubt, there's a reason. There's constraints within what you look at, the assumptions, and then you use it to help yourself. So I did not create work package 5's proposal, and from the beginning I was against it. But it's just survived. So this is what it is, and now I'm pretty much driving it because I want it to work. But basically, the proposal says that we're going to model the whole of KZN with all aspects to be able to inform planners about things like development and agriculture, whatever. It's extremely unrealistic, in my opinion. It's not in my personality, it's not the way I work. But anyway, but I must say, and I've noticed it here, this thing is bringing people together, and then some work gets done, and that's the way I see it happening. But getting back to, I've whittled it down now, at least for the first while, to one catchment area. The Mgeni catchment area in KwaZulu-Natal is a very important one. So basically, it's got the city, it's got agricultural land, it has got some natural land in it. So to start off, we've got the hydrology department at UKZN, and they seem pretty good. They seem to know what they're doing. They have some data, and we've got one of our members is a member, well, loosely maybe 2 of members, but definitely one is driving it from that department. And we've earmarked 2025's money to clean, curate, whatever you want to call it, data they have to make it usable for us. So I'm not an expert in this at all, but the way I see it is there'll be this hydrology and structural land data, because they'll have that as well. In other words, what do you call it? Terrain. And then we're going to build up layers with different members, and we do have various members, right up to town planning, where Koi here comes into the picture. We're very pleased that he came. So, so that's it in a nutshell. It's I'm not going to try and explain how it's going to work exactly. I don't know, but we do. So for instance, is Ursula online by any chance? Do we have anybody online? So
Yeah, I'm online.
you're online. Oh, I wish I'd known that from the beginning.
I'm here since the morning.
Are you happy enough with what I've said so far?
Sure.
Ursula is the leader. I'm not. She should be talking.
No, Kevin, you just introduced yourself as the leader. You're doing fine.
I didn't. I'm the driver. Did I say I was a leader? No, I'm not. I'm the driver. I'm the behind the scenes driver. But Ursula is a classic example. She's a marine ecologist. Are you? Oh. But she's an ecologist that looks at water stuff. And so she's very interested because she looks at estuaries a lot. So she's interested in what the data is going to give her. And then she's going to add that to our model. Am I correct, Ursula? Something along those lines.
Sounds about good. Yeah.
So we have some expertise, but we're a bit of a diverse group. And we're open to anyone, just like Kang's saying, to add to this little picture. And I'm determined to make it work because I have a portfolio, it's a bit unwritten, but it's there, of creating interdisciplinary work at UKZN. So, and this is an obvious method. And I've seen it working. I mean, as an example, as critical as I am of this whole thing and the amount of funding, there you create a new package 3, and there stands someone who says, oh, I'm so excited about this. I've got money for a postdoc to do this work. We just got to find the postdoc. It just shows that there's something working. So, you know, I am being positive. Okay. Is there anything else? Any questions or? Thank you. Ursula, do you want to add something?
No, I think you described it well.
Yes,
Why specifically KZN?
because we live there.
Okay.
But
Have the access.
yeah, well,
Would we
I
integrate framework from the West Cape or the Northern Cape or?
could have been.
Okay.
But as I say, I didn't come up with this idea.
Okay.
But no, I think, well, it is a very important area. Yes, Ursula?
Sorry, I just needed to cough, but Kevin already pointed out that the Mgeni is very important to KZN and eThekwini. So it's one of the biggest rivers we have, and it's the main freshwater supplier to eThekwini. But it also has a very important estuary attached to it, and the estuary is important in terms of biodiversity. And as you may know, there are very important sites as fish nurseries. So juvenile fish grow up in nurseries, in these nursery estuaries, and then disperse into the marine environment where they can be fished. And everything that happens in the catchment, we can see back in the estuary. So if there is water abstraction in the catchment, we see it back in the estuary as high salinities. If there is land use change, we see it back in increased sediment loads and increased nutrient additions. So that's why we wanted to have a whole catchment approach rather than sort of individual ecosystem approach.
And there's huge problems. I mean, there's development problems, word town planning, for want of a better word, or maybe just rampant a need to live. So it's a complicated system. That's why I think it's a bit naive to try and get to the bottom of it. But I suppose it's got to be done. I don't know. Or it's a useful thing to do.
what's the perspective to expand this to cover the entire South Africa?
Well, no, first we've got to cover the entire KZN, because that was the original thing. But I guess, but I don't know. I mean, because like I say, it's not the way I think. So yes, bigger and better, I guess. But what might be nice is that illustrate how this works. But but by the way, so I was in Mozambique about a week ago with friends, and some of these friends come from overseas, and one of them is a consultant in South America on very similar things. I was telling him about this project. He said it's exactly what we do. But now this is from a more practical way of looking at it. Like we're scientists trying to build knowledge and then supposedly give that knowledge to managers, which I'm already skeptical about in some ways. But I think they come at a much broader level. And so he said they use a package called Invest. Anybody know about it? I downloaded it. It's, you know it?
Yeah, that's what we used in our Mozambique study with World Food Programme.
Okay.
We did Invest modeling.
Okay.
Yeah.
And what's it? Because to me, it sounds like, but what he told me about it, it's a solution because we're never going to get down to everything and do everything and be great. But if we are trying to get at some kind of broad solution.
Yeah. No, it's useful. We did like water yield and carbon, pollination services, like you input like pollination networks and things like that. You just need one person dedicated to doing the Invest modeling for a few months though, to really understand how it works. Because there's like a lot of, you download a file and then another file, and then you figure out how this works, and then you input a layer. So it's pretty much just like you add the layers, you add, you know, some like numbers here and there, and you run everything. But just to get to that point, making sure that everything's clean properly, it takes a few weeks or months to figure out. But it is really interesting. I can show you some of the stuff after this if you want to see some. We haven't been able to publish any of it because it belongs to WFP and it's conflict sensitive. So it's
You mean the data or the area or
the
whatever?
data.
No, but that's not our problem. It's not because of the software.
And I mean, you can do all the Invest modeling for that area, any area really.
So
With
which work package are you in again? One. Everyone's in one. Okay, you're now in 5 as well. Thanks. Yeah, well, we can talk afterwards. But I'm interested because I don't know. It's kind of big versus modeling, but maybe not. Maybe it's better, and that's why I'm leery to. I mean, anyone can join in, whatever. But I need to still talk to my hydrology people. They've got some advanced modeling stuff already, and data, and so. We might be up and running faster than we realize, or we might not. So, yes.
Computational power have you got? Got your HPC, or are you planning to use cloud computing? When you're looking at these, I mean, it sounds like a smaller area, but it's still a lot of data.
Okay, that's a scary question. So I don't have a good answer. And I can tell you, because I did an honors project last year on topological data analysis. And we hit a wall fast, and supposedly UKZN has access to some big computer power, and we couldn't get in. And I was very intrigued. I'm skeptical about so many things about this NetTest, but then I heard there's talk of getting some kind of license to this kind of thing, and then if you're a member, you can use it. That kind of thing would be very important. But what do you have? Well, I mean, Not that I'm trying to steal yours. What I mean is, what do people do? Sorry.
Some mini HPCs at our lab, so
Oh.
we can access them remotely. via the
This is huge because it's not just manpower.
No.
I don't know what resources we've got. That's
I
a very
was
good point.
also excited to see that Francesco put that in his presentation, that it was some computing infrastructure that Nitex was going to provide.
Yeah.
But for now, I mean, I try to write as I can that actually splits it, so parallel processing, so that you don't need to run it all together. When I do, I can use our mini HPCs. We're fortunate enough that we have an agreement with Purdue University in the States, so I can access their HPC. But we've got some budget for cloud computing that we're gonna try and figure out how we can use it. And if we can figure that out through the School of Data Science, then we can hopefully share it. But I still need to figure out how to do that.
See, I don't know how much power the hydrology department have, for instance. etc. How much effort does this invest take that you know about? I mean, does this take a lot of computer resource?
No,
No.
you can run it on your laptop.
Oh, that's another reason I'm interested in it.
Yeah.
So it might be broader strokes, but it might do something. But I don't know. I don't know who's. A lot of people say you've got to get the stakeholders involved. I don't know. Who are the stakeholders? Who's going to care anyway? Oh, yeah, have you got any answers? But that is an important question.
I think now we're gonna just quickly get into the discussions on whether we need an integrated system in South Africa. Let me just quickly go to some. So I'm just trying to imagining what is an integrated system for ecosystem and biodiversity modeling. So in ecology, we have tons of different evidence types, different data. We would like to integrate that in, eventually provide us a strong evidence of biodiversity changes. Yeah, there can be population rise, fall, outbreaks, and can be community transitions and so on. This is a paper just out today, is the embargo date, I think the UK time or something. What this paper is about is future scenarios for British and Tajini biodiversity under climate and land use change. And what they did is, in the under the future climate for different species, taxonomic groups, the novel bioclimate conditions and the disappearing ones, so that they can inform the UK conservation agencies to plan ahead of specific kind of conservation strategies and so on. So in this project, they divide the UK into a grid. Okay, so in the grid, they have records of presence, absence of different species, and coupled with environmental data and future scenarios, then they can forecast potential distributions, potential compositional turnover of different all species taxonomic groups into the future. And they can identify vulnerable areas. So some combinations of species and climate is disappearing. Disappearing maybe not as extinction, but it could be this combination is moving into Europe So the climate cannot host such species in UK. In South Africa, we also did this very similar thing. Yeah. So this is before that is in South Africa, we have a huge amount of data. This is Google. What is this? Ecosystem, Global Ecosystem Atlas. It provides a fine spatial distribution of different kinds of ecosystems in South Africa. This is the part of the Alpha. What is it? Alpha Earth. As part of the Alpha Earth from Google, they also provide this Global Ecosystem Atlas. And I think that lots of data can be directly accessible. And when we're talking about Earth systems modeling, coupled with oceans, rivers, urban, rural, and all the different players in the system interacting, having complex feedback loops. So eventually, if we can model the entire thing, that's a Earth system modeling. But if we only rely on the products from, we rely on the physical geography, layers, boundaries, coupled with climate and so on. So we don't predict such things. We use the data products from them. We only kind of concerned about biotic compositions, distributions. And this is what I mean by integrated biodiversity and ecosystem model. And it's a dynamic model so that we can potentially reconstruct the history and predict to the future. Depends on the data, of course. If we have ample data set, this is from the GBEF data set. If we have sufficient amount of data, we can have fine spatial resolution and temporal resolution. But if the data is not adequate, we have to consider very coarse spatial scales. But it might as well, we can do an exercise. A coarse resolution integrated biodiversity and ecosystem model. Here are some examples. This Ashley's master when she was doing her master. So she forecasted dragonflies' future temporal turnover in South Africa. So it's under different scenarios. And this one is also basically is to distribute the species richness and compositional turnover of vascular plants in Africa. So this one is based on model data of 23,000 vascular plant species. But all of those are snapshots, yeah? So the snapshot by 2070, this is the anticipated, at least, the anticipated pattern. And can we develop model which each grid cell have a system of equations to govern its interactions, recruitment, and all sorts of things, demographic rates within that grid cell, so that we can reconstruct and backward and forward running that to predict the spatial temporal dynamics. In South Africa, we have very strong teams, yeah, in this domain. So this is Haley's their work. This is the biodiversity, not biodiversity, landscape intact index. So where are the areas under strong anthropogenic disturbance? You can clearly see. And this is, I think it's based on dynamic vegetation models. To see where different biomes in Africa are going to shift. And in the future, whether such conditions are still going to be there. So there are lots of data products out there regarding South Africa and Africa. And Haley is based in the CS Resilience Center. It's just down the road, it's just here. And this actually, the last author is Jesper, so it's part of the SEEK group. So, last year, this is in the news, in the Nature news about the launch of NETAX. And the idea, because I want to remind everyone, NETAX is not an ecological conservation agency. Their kind of mandate and focus area is maths, data science, and AI. And we have to think about that, because if your question is complete conservation, they're not interested. They want to see maths, data science, and AI being used, applied, transform our ecological understanding. Actually, E5 is within the bioinformatics. We are packaged as quantitative biology. And we call that bioinformatics. Sometimes we also call this field eco-informatics. That's why I think the genome research is very important. Bioinformatics, we don't have the bioinformatics folks join us. It was here right in the beginning. But I think there was lots of teaching commitment, run the curriculum and so on. So we are essentially running this. Again, to remind us, we are running this unraveling complexity in coupled Earth, environment, economic, ecological, and evolutionary system. And for us to run the evolutionary system, we need to know the traits. Yeah, so the traits will inform how species are interacting. It doesn't have to be life history traits. It can be strategies. In your system, you have multiple players. How two players are engaged and interact with each other depends on its strategy. And of course, each player will sharpen their strategy. So that's the adaptive part. In evolutionary term, and then we can quantify that using genetics and phylogenetics. Ecology part is essentially abundance, interactions. We have to quantify that. Distributions. Yeah, so community compositions. So it's ecological performance. So you have evolutionary performance, ecological performance. And of course, I mean, we have lots of related economic things, components, harvesting, agriculture, and environment is all embedded into this environment system. And Earth is just providing us some physical boundaries. So this is, I think it's in the NASA, some kind of research group trying to introduce what is system modeling, Earth system modeling. So I just borrowed this one here. The main thing is we have to have a grid system. So this is basically we divide the planet into a grid system. In each grid cell, there will be players. Players will interact and then they can move between. And we basically use a set of equations to describe that. And then they can move horizontally, vertically, and also in this sense, vertically, if you want to model like the ocean system. If you want to also model the climate system, you can also have different layers in the atmosphere. And this is one example, because we are, in any case, we're going to run this program at the end of this year. So our team and a few colleagues, collaborators, I've just been awarded this HFSP grant. So basically it's modeling upwelling ecosystem food webs. And the plan is you have an upwelling system. We divide this into layers of different depths and also spatially into grid cells, grid cubes. In the grid cubes, you have different species. They're living at different depths. They form food webs. They have to escape each other. They have to move. Whereas the upwelling current system bring the cold and nutrient-rich water to the shore to support the food webs. And there are 4 major upwelling systems in the world. So we have 4 partners, each one is handling one. But the model, we are handling all the modeling here. So this is one example of system modeling. And this is the paper I just found that in ecological informatics, talking about a unified framework for digital twins, because it looks like that we are reconstructing this ecosystem in our computer. So it's dynamic, and the player is in each grid cell is interacting with each other locally. Of course, they can move outside. And the first thing is we need to decide on the grid system. This is SABAP, the Southern African Bird Atlas project. So they work with this quarter degree cells. You have, I can't remember, quarter degree cells, roughly speaking 25K by 25K. And most of us actually, when we work on macroecological patterns, we work with quarter degree cells. I think SABAP 2, so you have a much finer scale. And lots of recent studies also work with 1K resolution. But again, it depends on the kind of data, yeah? So lots of those data that we can compile are from Atlas, for instance, Frog Atlas. You can imagine those published books. Those are at quarter degree cells. So we can't push to the finer scales, but we can work with some existing data to see. So for instance, this is a project that we are collaborating with lots of partners, and Sandra is pushing through running lots of data cubes projects. Basically, you can package GBAF data into cubes. But if you think about the cubes, it's essentially this what we're talking about. You can consider each little pixel is a wide range of taxonomic groups and species, and also associated environmental variables. That's we can call that a 3D cube. And then and that will give us a system structure of the entire country and its oceans. Okay, that's all. The question is, for this perspective piece, do we need such an integrated biodiversity and ecosystem system models?
Do we need it, or do we want to do it?
Do we need it? And then if we need it, and then we can identify the key components of such model and what we are lacking. What's our next step? That's basically this perspective piece is about. Okay, I'm just gonna.
It's a very useful exercise, at least, to show how all of these parameters live together. So if you're going to be building a digital twin, it's not just about each of the layers, it's about how these different layers interact
Yeah,
to create outcomes. So from that point of view, I think it is useful and we should do it, but it's not going to, it needs to be understood at the level that it's created. It's for a general understanding. You can't go and use that for park planning, for example, or
of course.
smaller areas. So, and there's some people online, I see hands up. I don't know. Ursula wants to say something too.
Yeah, Ursula?
Hi, thanks. I was just going to add, I also find it a very important and very useful exercise in general. Maybe one point I'd like to add that Kang was talking about, that we have a lot of data. We certainly do for some ecosystems and for some species, but for others we actually don't. And we really don't even have the foundational biodiversity data. And so we obviously can't wait till we have all the data we would like to have for such exercises. And so it would be very useful to talk about the data requirements and what can we do when we have those data gaps. You know, how we obviously can only do so much, but I think it would be a very useful exercise to lay out, you know, how far we can go with the type of data we have, because around the globe, like somebody mentioned, or the global north was repeatedly mentioned today, in the global south, there are many places, and also in the global north, where the data are not available. And so I think that would be a very, very useful add-on to this exercise. And the last point I'd like to make to this, if we can add on ecosystem services, we just had an Ocean Innovation Summit here in Durban, and we saw how huge the gap was between the so-called blue economy, like making money out of the ocean, and the science that feeds into that regarding the natural environment. So there is a complete lack of understanding. There is, you know, it's sort of, we're capturing carbon by farming seaweed, but then the seaweed species come from Indonesia, and so a real disconnect. So I think, you know, not maybe, you know, I wouldn't go as far as planning, but I think we could add perhaps an ecosystem service layer there. Thanks.
Yeah, I think it definitely is necessary to add those ecosystem service, like the multi-dimensionality of ecosystem functions. Yeah. But I think as an exercise, what I'm thinking about is this kind of macroecological patterns. We have lots of data, yeah. Bird atlas. We have dragonflies. We are actively working on dragonflies for the countrywide. We have, if you can think about it, yeah, dumb vetoes. So lots of insect groups we have data, amphibians, birds, mammals, and who mentioned it? Lauren, you mentioned Chris, that the Nano Atlas, they're updating that. So we have lots of those data layers. Yeah.
So I've heard twice now, Sandra and now Ursula, say this is an important exercise, and then say why you can't use it for planning or something. But I'm just interested, why is it an important exercise? What's useful about it?
But I think, well, first to echo something that Ursula said, it's will be an important exercise to highlight the gaps in some of the data sets. So I spoke this morning about my worry with the ease at which remote sensing data can be downloaded and then it's used. But it's you don't take into account the collection of that. The same with if we were to do an exercise like this and we use GBIF data or iNaturalist, it's an opportunity to highlight that you can't take that data at face value, because if you do, for example, in Kruger, the roads are the most diverse habitat. That's because they're recorded on the road because they're by tourists. So even if we just use this platform to highlight those limitations so that people don't make these mistakes, I think it's a useful exercise. And also to start thinking about how all these components could interact. I mean, I think this is going to be a much bigger project than Can Things. But, I mean, for you, I would think you would jump at it because essentially this is what E5 is, or Work Package 5 is going to do. Put all these things together. So this will be a blueprint for you.
The way around. But I don't know. Yeah.
Depending on how fast this happen. But from my perspective, that's what I think it would be useful and important. Some levels.
You share.
But I think also, you know, why I think something like this would be important, because if you look now at the statement of the NITEC about AI, computers, big data. The thing is, like you say, this is like a horizon scan now. This is what we have. This has been collected, various platforms, you know, from citizen science to whatever we can put our hands on. That's what we can produce. And the ultimate thing here comes down, what is the service the ecosystem can provide us with? You know, and given what we have, can we actually say anything? You know, just collecting more data doesn't mean we're going to solve the problem. Like you say, the sensors are not in the right resolution, whatever. So we have to do something and say, this is what we have. The UK has done X, so their data is in that resolutions, it works better. We are sitting with this. We will never get there unless we solve this problem. So we have to get to a point to say, oh, this is where we are right now. This is what we can do with the code, the AI, the sensors, but this is the limitations. So this is what we have to get forward. Like you say, it's going to be probably coarse for some species, but very good for other species. And given the good species data, is it useful? It's probably useful ecologically, maybe for ecologists, but for the government making some decision around ecosystem services, it must be useless. So, you know, that's what I think should be coming from a paper or the analysis like this.
And it can be used to leverage resources.
Yes.
Once it's published, you can say to NITEX or whoever funding source that these are our gaps.
Yeah.
We need to fill them because you can see we couldn't answer this question completely because we didn't have that.
Yeah, I mean, if you look at the bird data, but atlas data and the butterflies and the dragonfly data sets, it's really nice data sets. But look at mammals. There's thousands of camera traps in the field. There's just no coherent place for camera traps. Mammal Map tried, there's some options, but nothing, there's no coherent place where camera trap data sits. You know, Sandy's got some, but it's so disjunct. Whereas birders, you know, they tend to report it goes to a bird atlas, it's curated properly, you know, it's sitting there. So it's quite useful data set. Whereas the other ones are a little bit of a, you know, I don't know how much of the fish atlas data is also available, but you know, the river ecosystems is also an extremely important one to model around, you know, because the rivers are changing rapidly in South Africa. It's infringed by people, so that's a good ecosystem service type of thing to look at. But I mean, that's what I would think comes out of an analysis like this.
Yeah, I think the freshwater system, they also, that database is there, yeah?
Yeah.
I have it, but I don't think I'm supposed to.
We have Sandra, so.
Person is going to hand up.
Thanks. I just wanted to add, if it is about a proof of concept, I would really love to throw estuaries in the mix there, because then if you say that for some terrestrial species, there are very good data sets, and we would have a nice gradient from very good data sets to you know, to not good data sets at all. And I think for sort of a proof of concept paper, that would be very useful to say, you know, it works well if you have this kind of data, but if you have that kind of data, then this is what we actually need to do with it, and this is what you still can get out of it. And if we use something like GBIF, for instance, like that was mentioned before, that would be sort of a, you know, quite a nice source to use and quite yeah, objective. Thanks.
Maybe if I can just, again, maybe one comment extra. What if we also turn it around and say, given the country, you know, what ecosystem service are needed, or what is the most urgent ecosystem services we have or needed, you know, like water filtration, purification, those type of things. And can we have it spatially, right? And then when you do a type of like a dynamic model or something, you impose the stuff on it to say, how do they map? This is what we can map, and this is what so we might want this ecosystem, like the estuaries, we want it here, but the data plots here. You know, what is that? I'm not sure if it's a, you know, a feasible thing, but you know, it's almost like saying I need X, but I have Y. You know, I don't know how feasible that would be.
Matthew Roget did some in some national reporting. I can't remember which one it was, but he looked at mapping the ecosystem services, as you said. So I don't know about now, but it is something that has been done and can be done. So we can definitely talk about it. Think
But
about
if
it.
it was done, there might be a data set to tap into.
It's definitely a data set. I don't know I mean, I know what it looks like, but I haven't really used it, so we can explore it for sure. It is something that can go in here.
Yeah.
Before we kind of continue to discuss on this, Marco has a proposal.
I'm sorry to be outside of the program, but yeah, I must leave very soon. Thinking in all of the discussions, so I was drafting something, because obviously my area is a little different. So I would like to see how we can fit that in certain of the areas that you are discussing. So you see that I put like a working package or activity in a working package. So it's mostly to explain you if you think it's a good idea or not. So we have this problem that is the spatio-temporal modeling in our experiment. Okay, there's a lot of variability when we collect certain data, physiology or data that we have on a spatial scale. Obviously, that's very small scale, so don't think in a big scale because it's agriculture. But that can be a problem that maybe you, with your expertise in modeling and other areas, maybe you're interested to tackle some of these problems. Yeah, my question is if we can maybe create like a mini workshop or something that some of you and maybe other people can be invited to discuss around this topic, develop a framework, maybe from some other disciplines that is not agriculture can solve this problem easily or not. That is one of the points. I don't know if it's clear enough what is the problem, or you can tell me. And the other idea is something that is quite nice in terms of what we do in agriculture and in viticulture. So it's this one in terms of bioclimatic indexes. I don't know if are you familiar with this concept. So we use some of the bioclimatic indexes that are specific for viticulture. So there's some studies from Europe, for example, they can map what type of cultivars and certain conditions are suitable for certain type of grapes. And as climate change is changing the conditions, the distribution of that in our country gonna change in the future. So this also it's that type of idea, maybe a little workshop that I can have with you, see who has access to certain data or who has the expertise to simulate future scenarios, so we can see where in the country are areas that we can plant grapes, which areas we can avoid in that sense, and also probably it's more specific in certain cultivars, because the description of those bioclimatic indices is quite simple. It's just certain calculations in base of temperature, soil moisture in soil moisture. I think mostly temperature is the main driver of those indexes. So Yeah, so very briefly, to not use a lot of time. So I think these two ideas, I don't see itself is like a working package or create another working package. Maybe it's better to do like a 1 or 2 mini workshops, invite some people that you can help me to select or yourself, and we discuss 1 or 2 hours, and then we propose something that can be a project, that can be a sharing certain things, or can be an article if the data is available. I don't know if it's clear enough. Any questions?
Your first activity there, I mean, that's exactly the problems we sit with in ecology, is that you have your sites and you can identify different drivers. In your case, you're looking at the phenotyping, and the variability within that site is unknown often. So it's not just, often it comes down to data, that you don't have the resolution of data for each of those parameters that you have on a site, but then also those interactions. So, I mean, the easy way, you've written it there already, is your mixed effects modeling, where you just put it in as a random effect and then hope that you extract the other key ones.
But actually, in this case, it's gonna be very nice for you to do something like that, because I know the final answer. I know, for example, the behavior of those vines in terms of water stress. But I don't know very well from which are the sources of variability, because we have some treatments, we have different plants with different conditions, and we have data for most all of those points in grid analysis. But that variability is so big that sometimes is a confusion with the treatment effects. So that is the part where we need someone with good ideas in that sense to analyze that. Actually, the paper that I put there that Bernardo is just published a month ago. So it's the only one that tried to addressing that problem. And I think in your case, from an ecological point of view, maybe it's a problem that you are dealing with for many years. So, but in our case, it is not a lot of experience in how to manage that variability or heterogeneity in the data set.
The unique opportunity, because as you said, you've got a lot of detailed information that we don't capture. So we can start teasing apart that variability.
If it's something that maybe you discovered that a model or something that can be extrapolated to another type of applications later, maybe it's a way to do like a little ground truthing of those theoretical approaches and see if some of them can give something. Yeah, so I don't know how we can go forward with this, but maybe I can work a little in the documents and share with the group. And then maybe some of the work package leaders can say, okay, I think we can take a little more charge of that and we organize something. Because I see a workshop can be a very nice first step to have more time and calm to discuss. I can bring some examples and data, that type of things.
I mean, especially along plant functional traits, we are trying to figure out how plant functional traits can be correlated to the performance of particular species in a local community. Although we don't have very fine scale data.
You would have trait data that changes over time.
Yes.
That's exactly what we were looking for.
Yeah, we have 3 seasons of data or 4 seasons of data. So we are following actually a vineyard that is a university premises from the moment that we plant, from scratch. I have soil layers, plant layers, the condition of the plants, some microorganisms, the stomatal conductance, that is physiology, fluorometry. I have some drone data on top of that, satellite.
I mean, that opens it up. So you've been very quiet, so now you have to say something about evolutionary scales. You can start teasing apart just these fine scale trait changes. Modeling
and
real data.
Something simple for us that is not so trivial is how we can present that. So if we can manage at least to present the data in a way that can be easy to access to that, instead of putting layers of layers of one on top of the other, that is impossible to extract certain patterns. like a more metadata analysis if it's possible in a certain way, and or sources of variability, which factors are getting more important in that variability, because our treatments are not showing very clear patterns, but in certain areas of the block, it's one small plot, but we know there's certain plants with exactly the same genetic that are performing much better than the others. And it's the same soil, it's the same irrigation, it's the same cultivar, there's no other changes. We are not sure why. And I think it's mixing in terms of the data.
There's also probably interactions between all the.
Interactions, we are not doing any type of analysis with interaction. Yeah.
Vernon.
Have you come across the bioscape project? So Jasper Slimke, who's my group, NASA.
Yes, I know the bioscape, yes.
Yeah. I mean, that might be a nice thing to integrate with your stuff. That's the next generation of satellite products that are gonna. So it's only a one snapshot.
That is hyperspectral, I think so.
So they do a whole bunch of things.
Yeah, I know a person that is from geography that was managing that, but yeah. But if we can access to that data set for this area, that'll be amazing.
So I just pulled it up now, and they did actually fly over Stellenbosch.
Okay, no, that is great because we have some ground truthing information, so canopy and other things. And also for the other project, if you have access to climatic databases or if you are expert on modeling with some of these climate change scenarios, that is something also very, let's say, easy, but extremely important, and no one is doing that. In Europe, there's a lot of experience. There is a package, our package that they publish in Italy, and et cetera, but here in South Africa, nothing. So we are following European
Actually,
policy.
5 years ago, we had a whole team from the US. They were trying to kind of develop biologically inspired by index.
Okay.
So it's very similar to what.
So in a certain way, these bioclimatic indices for viticulture have been done since 2005. So it's just matter to apply that in the context and recalculate that for the country, similar to the picture that you show when we can see in South Africa where are the areas that viticulture going to move. And if we want to go further, we can see if those areas really exist or not. So, yeah. Because
actually, we can do this for the major crops in South Africa.
yes, I think maybe a starting point is with what we know. We have some data, but then can be extrapolated easily to other crops.
Especially by performance calculation.
Yes, yeah, for viticulture that is very well documented. Maybe
Yeah.
No, we don't have yield, but we know, for example, one of the indexes in terms of temperature, under certain range, certain cultivars going to work. And outside of that range, it's not possible. So then you can recommend to the people, don't go to that area and put that type of cultivar. Because then you're going to be outside of these ranges and your quality, your yield going to be wrong. And then you're going to need to replace and move your. And other areas that maybe not common for viticulture are going to start appearing like, okay, now this area in 10 years more probably is better to use that zone. So these are the two ideas. Sorry for just interrupt the previous discussion, but if you don't mind, I can compile this, send all of to you, and you can tell me if you're interested and how we can work with that, because I think a mini workshop with people that know what we're talking about, having some data can be extremely beneficial, and we can maybe, I don't know if we can easily end with an article, but at least with a framework.
Especially the data.
Easy,
Yeah.
yes. Okay, thank you.
Thank you. Oh, sign me up. Let's go.
You're involved in everything.
That's my problem.
So we identified Sandra as the champion.
We're coming.
We still have 2 hours to plan ahead about this perspective. It has been personally invited for us to write something for South African Journal of Science, especially as what is this focus area? Yeah, so from this the perspective from this focus area. Do we need this such modeling exercise? If we want to do this modeling exercise, what kind of questions can we address? What potential gaps we need to fill? Yeah. Thank you. Let's go to the other piece.
There's only 4 people, the other 4 people are us.
Functional traits, James. I thought you'd be jumping.
James, Janet.
What is this?
Hi, Sandra.
Hey, James. I was just asking if there's any of the activities or packages that you want to contribute or are interested in. I was thinking the functional traits one. It made your eyes sparkle.
So I'm interested in plant reproductive traits, but those aren't really the ones that you think that you're thinking of functional traits in a different sense or a different dimension, the more ecophysiological stuff. So I don't think functional traits would work for me. I am potentially interested in things related